Also,
Okay.
do I have permission to share
You need privileges.
privileges?
You guys have privileges now.
Oh, great.
Nice.
Okay, so I'm gonna share and we can talk through some things. Can everyone see this?
Yes.
Yeah.
Great. Okay, so there's a lot of technical stuff in this presentation. So before we get into that, I want to give some motivation so that we don't lose sight of why we're talking about this. And kind of, I want to get across like really how ambitious our overall program is and make that because when you go through math, it can really seem like you're kind of trying to work out these small details, and if you don't see why you're doing it, it can, I think, kind of impact the morale. So we have in the primer and elsewhere been talking about this idea of bodies that are capable of some kind of subjective formalism, right? So we took this idea from Badiou that among all the things in the world, there are these things called bodies, and they are capable of kind of conforming to some idea. And this can kind of manifest in many ways, but our group is most interested in the political aspects of this. So I think there are many examples in politics of bodies, which are definitely not individual bodies, but are comprised of like large collectives of people, and may span multiple continents potentially. So like some examples would be a protest, a strike, occupying some land, like for example, like in the United States we have the Line 3 pipeline. They're currently occupying to prevent this from being built because of the environmental impacts of this. And in general, we want a theory of how coordination can happen that aligns with Badiou's concept of the body, but also has some more practical things we can really build on top of. Because unfortunately, Badiou's theory doesn't give us a lot of details about how the individual parts of the body work together, right? There is this concept of organs, and there's this concept of relations in a world, but there's not a lot of detail there. Like relations is a really short part of logics of worlds, and organs, although Badiou does spend quite a while talking about this concept, you really don't get a clear understanding of how the various organs of the body coordinate, how one impacts the other. All you really know is that they kind of refer back to these points and overall to this kind of lattice structure, which is very vague. So that's why Yash and I are really interested in this text on behavioral Mereology, written by Fong, Myers, and Spivak. It's a very recent text, and the really nice thing about this is it gives us a way to talk about how parts of the body relate to each other in the language of constraints. So we'll, of course, go ahead.
If I could add something, I think to start, I think the best way to think about this is it's a way to describe what things are in a general way in terms of what they do. right?
Mhm.
So it's
Mhm.
when you have some kind of base objects that are given and they have possible behaviors, and these behaviors pass to parts in some way that is determined by the behaviors and not necessarily the physical stuff, right?
Yes.
So it's, I guess, an attempt to show how can we formalize thinking about behaviors and thinking about the logic of behaviors, which I think is pretty clear how this applies to us. Like in the primer, you already have, for like a commodity, you already have two sets. You have an exchange set and a use set, which are both already behaviors, right? So I guess we'll see
Yeah, it's
connections probably.
really, yeah, it's a really good connection there. Yeah.
Yeah.
The nice thing is, okay, so we made this proposal in the primer that there shouldn't be a distinction between organizations and economies, right? Like they're kind of interchangeable in terms of their logic. Maybe their scale is different, right? Economies might be one large form of an organization, but we want the same formalism or the same platform to talk about both of those things. So yeah, definitely behavior seems like a nice paradigm, or like a nice common set of tools to think of how these different bodies work together, right?
Yeah,
So
also I think at least for myself, one thing, just I guess sort of anecdotally, there's, I think a lot of often I think thinking on the left already sometimes has this perspective, and often critiques are done from the perspective of instead of like essentializing something, you think of what that thing, whether it's like an institution or whatever, what it actually like does, how it actually functions materially. So it's like a good way to tie things to their actual like material being in the world, right?
could you say that again, Yasha? Like, you mean?
Yeah, no, I was saying often you hear in I think in just like leftist critiques in general of various kinds that I've heard around. Often the direction is that instead of necessarily like looking at something by what it's composed of or like essentializing it in some way, you look more at its function, what it does, right?
Right. Yeah.
Not to like say this is like gonna always make everything objective or anything like that, but as a general thing, it's good to pay attention to what things do rather than just their composition. So
That's a good point. Yeah. Especially when we're talking about political tactics, and like they're very goal-oriented things, right? It's really about achieving some effect in the world, and so you really care more about that than you care about like what is the direct compositions.
I think that a kind of more straight to the point way of talking about that, because I mean, you can also fall into problems with this sort of, things are just what they're doing kind of description. I'm not sure how useful it always is, but I think that, for example, when Renzo brought up that idea that, like the text that we mentioned a couple of times, right? The one that talks about memes and politics and sort of how to consider this age of revolts as something that is actually a new way of thinking about politics and not just a kind of faulty political thing. And the guy starts the text with that claim, right? That contemporary rationality for politics only know radical actors and not radical actions. In other words, like it can only tell apart radical things, but not radical behavior, right? I mean, you can accept that a party called Radical Party is a radical party. But if there's something slightly anonymous going on, we don't have the tools just from the effects of what's going on to talk about if it is radical or not. It's easier to map the forces by referring back to the actors, right? So behavioral Mereology seems also a good way to kind of address that sort of problem, right? To have a conception of right actions rather than actors, or to define actors by their actions, right?
Exactly.
Yeah.
Yeah, and what you said, it's important that, of course, it's not a full description of everything. It's not that everything is merely what it does, but it is like this perspective, as is like any, I guess, like category theoretic perspective, is like some filter of looking through the world. It's choosing something that is important. This is saying, we're looking at behaviors. Let's see what I suppose like we can do with them.
You know, something that I mean, just before you move on, but if you guys can comment on it as you move along, really interested me reading the text. Like, it begins with this very classic kind of pragmatic. I mean, a lot of philosophers will be very happy with this idea. X is what X does, right? A sort of pragmatic look. The set of uses of the thing is the thing, right? But I was wondering if there, because one of the things we are exploring is the idea that organizations are kind of like social experiments. So it's interesting to think about the inverse, which is sometimes you don't know the constraints, you try things out, some will work, some will not. Through the constraints, you learn what the thing is, right? So rather than saying X is as X does, you can say by knowing what X does, you know what X is, right? So you can learn about it through the constraints.
Yeah, I think that's a nice extension of this behavioral thing, because like we talk a lot about scaling, for example, scaling up things. And I think that you learn something about the body when you hit a scaling problem, right? You see like this activity, which was working on a smaller scale, ran into some trouble when it became bigger, right? And this happens a lot with I don't know, grassroots movements that become kind of feed into like something more formal, like a party, for example. Like parties are big, grassroots movements generally are small, and then it seems like you lose something when you pass from one to the other. And that would be, I think, a nice example that we could talk about.
Yeah, also from the paper on like the more, I guess, theoretical level, there is one thing, I guess, sort of along the lines of what Gabriel was talking about how there is, at least on the math side, that you can recover the order of the parts, and I think you mentioned this before, from determination, which is like a logical requirement, right? So if you can figure out how everything determines each other, you can recover the order of the parts from this behavioral perspective of like these behavioral parts. But we'll get to that. We can talk about it a little bit later. But I think that is kind of probably like the only thing really of interest in that regard that this paper has to say about that. But yeah, it is probably, there is probably more to do with that.
Yeah, but we can go into
it's
it
like
later.
More, yeah. It's more of like a setting up the context. Kind of.
And one more thing before we start. Another thing I was thinking of, which I'm just going to talk about briefly. I'm interested in this idea of cyber-physical systems that has been kind of a reference point for the applied category theory people. And I think that's one concrete thing we can get out of this talk, is an idea of a kind of language that can be applied to both people and software and you know, combinations of those things, because this thing we talked about, the platform for organizations is, I think, a cyber physical system. So it's a way that we have this intuition that we can take rules and encode them into these machines and somehow offload some of the cognitive burden of enforcing the rules, so that the human side of organization can focus on other things, right? So I think that's kind of a big component of any kind of large scale leftist movement these days, right? You need some form of, I don't know, online presence or something like that, it seems. So I think my wish from looking at this is to kind of take these ideas and apply them in that direction of a cyber-physical system.
Yeah, exactly. And along the lines of I guess cyber-physical systems, it actually gives a good way to, I guess, introduce a little bit of like the mathematical context of the paper beforehand, which is specifically something called the Curry-Howard correspondence, which, like what Dennis was talking about how I guess like some way to interact with something more human-centered and something like some computer model of whatever. The Curry-Howard correspondence is sort of this like type theoretic logic, general, I guess, approach / rule. It's not exactly like a theorem. A correspondence between proof systems and models of computation, which is sort of like, I guess, the basis of what is modern, all the people trying to make computational like proof checkers, which has been a goal of the mathematical community for a long time. And they're working on that stuff right now. But that's kind of the basis of that. And that's sort of where this started, which is connected to Lavier's original, I guess, discovery that in any topos in general, where we talk about topos as like some place where some math can happen, that universal and existential quantifiers correspond to certain adjoints to this pullback, which is basically like a context changing pullback. It's just some map between functions that changes context, and that the universal and existential quantifiers, which of course is like what you need to build a lot of logic, can come from there. Yeah, so that's kind of a little bit of the context before, I guess, before even getting into the beef of the math in the paper itself.
Yeah,
like
definitely.
What this is inspired by.
Yeah, definitely. I mean, this correspondence between types and proofs is really, really useful too, because at least the text here, I don't think it goes into it as much, but in other works by these authors, the same authors of this text, they also want to apply like the internal language of a category to prove things about systems, right? So
yeah,
you can, it's one thing to state like this is the behavior of a system. Okay, I said it that it is, but how do we prove that that behavior holds? And so you need a language to write those proofs, right?
Yeah. I should also mention from the Curry-Howard correspondence, you guys will already recognize some of the correspondences, like truth is the unit type or like the top element, right? And that's like from Badiou as well. It's the same thing. Falsity, like the false, is going to be the bottom type. Universal quantification is like a generalized product type, and that's like that's kind of into like homotopy type theory kind of things almost, but it's not super important for here. But
yeah, we'll definitely get into like all that in the next couple slides. Okay, so here is the topics, right? So we're going to start with simple part and whole relations, or relatively simple. And then we'll have three slides on constraints. And then the last thing is on this, what is kind of the central idea of the paper, I think is like these intermodalities or intermodal operators, which is kind of complicated, but I think it makes a lot of sense by the time we get to this slide. Okay, so part whole relations. All right, so I think the easiest way to talk about this is just to think of it in terms of sets. So we have this thing B of S, and we have this shape here that's called S, right? Those two things go together. So so S would be a system, and it is drawn like this because we want to kind of emphasize that it's an open system. It can be connected with other systems, right? When it can be divided, and the system is not the boundary of the system is not defined. B of S is a set of behaviors that this system is capable of. So earlier Yasha was talking about like use sets from the primer. I think if you want an example that we've talked about a lot, we could think of B of S as like the uses of a system, right? I mean, roughly. And then in the paper, they make this caveat that they're using the language of sets because it's more familiar, but really what they're aiming for is these objects in the topos, which are also called types. And just to kind of make a comment about the relation between sets and these types, you can kind of think of them as variable sets. So sets that are parameterized in some way on some space. And so B of S is not only just a set, but it's something that you can like slice up and glue together with other things, right?
Yeah, I think it's good to think about it as basically like where you take S as being sort of like the material support, right, of the sheaf of behaviors, and the sheaf itself is S plus some things on top, like that we think of as kind of on top of S.
Exactly.
And these are going to be the behaviors, but not that just it's on top, but they also have some way of factoring through its parts that is consistent. So this is what this restriction function is in the middle, right?
Yes.
So this is
the next
for any,
the next one is on that.
Yeah. For any part, you have the parts are defined this way, that it is a part not by its not by like the set S itself, but by its set of behaviors, right? Which is some subset of S potentially. And you have this for each part, you have a restriction of behaviors. So you think of having some S, you have some part of S, which is some other set that you don't really know where it's located exactly. But the way that you locate it as a part of S is how it factors through the behaviors, right? So for example, I mean, the example from the paper is like a bicycle. You can say the whole is the bicycle, a part of it is maybe the wheel. And obviously we know that we can look at it and say the wheel is a physical part of it. But the reason that we think of it as a part in this sense is because an action of the bike, AKA moving, restricts to an action of the wheel in that it turns, right? At some rate proportional to the gears or whatever.
Yeah, this is an interesting idea. Like you mentioned, it's not just that, okay, the wheel is attached to the bike, that's why it's a part. The reason is because, like you said, the action of the whole can be seen to be correlated between the action of the whole is correlated to the action of the part. Okay, so we can imagine a body that is not connected in space at all. Like if I send a tweet out on Twitter or something, and somebody responds to that, and it gets a lot of likes or something, that can still be thought of as a single body, even though there's no physical connection there, right?
It seems like there was a very important remark that they make on this when they said that we're not defining part in terms of subsets, but partitions, right? Quotient. Right? The point is not what is the extensive subset, so is the wheel a set of things or not, but the fact that, for example, if I have a body that is moving, you can slice the movement of a body to the fact that the arm was moving, and the fact that the hand is inside the movement of the hand always follows the movement of the arm. It's impossible to move your arm without moving your hand out. And therefore, if you move your arm, you also moved your body. So those are, let's say, the connections between actions inside of actions, right? Not connections between elements inside of elements.
Yes.
Exactly.
Yeah.
They don't need to correspond to the subsets straight up, right?
Yeah, so I think this is actually another reason why you'll see that this is actually, I think, more useful for our projects in general. And why, for example, like the bike example is actually maybe a bad example, because the part is sort of identifiable by its like being, right? You can see that the wheel is part of the bike. But for like a social, some sort of social being, or if you're talking about something on Twitter or whatever, I mean, the way that you slice it up in terms of the material being is a little bit harder. Very often it's easier to see what something does rather than what something is in a social world, right?
Mhm.
So that's maybe like a reason why to be interested.
Yeah, I definitely think, yeah, some work, we should definitely do some work to think of examples that might be counterintuitive for this
Yeah,
whole
I mean,
and part.
do you think that, I mean, they don't give any examples where a part is not somehow related to a subset, like an extensive subset? Ultimately, I think physical systems might require, I mean, perhaps we could talk about, for example, dynamical systems where the water molecules are changing every second, but a form is stable. So perhaps in that sense, we start getting a bit of a sense that things are moving away, right? Like there is no stable subset of elements that corresponds to the stable behavior.
Yeah, it might be difficult to find examples of this, for example, in like natural systems, right? Because the whole
like
point is that there's some materiality, right?
Isn't that a whirlpool? Like
what?
For example, you have like how we call when the water is going down the drain, like a whirl thing.
Whirlpool, sure.
Yeah, sure. For example, if I have the water going like this down the drain, it forms a kind of a form there, right? I cannot describe that form directly on the molecules below because they're changing every moment. I cannot correspond that form to a subset of molecules, for example.
You can with loss of information, and I think that's this. So this arrow here, it's like a quotienting arrow. This doesn't suppose that all of the behavior survives the passage to the part. Only that there is some behavior here that corresponds to some behavior here, or some set of behaviors here.
And then it's a surjection, meaning that it hits everything in the part, right? So the whole should cover the part.
Yeah, right. The thing that I'm trying to understand is the following. Like, there's that guy I really like, Terence Deacon, and he has that distinction between thermodynamic, morphodynamic, and teleodynamic types of work, right? And he tries to give you a genesis of how, even though you have, let's say, materials, non-materials and systems materially acting on one another, the production of certain stability in a system, like a formal kind of attractor or whatever in a system, you need something of the same consistency to intervene on that. So for example, if I have a certain whirlpool, whatever, some water going down the drain, and I have plenty of water, right? So it's just going down, it's raining. If I just put more water, it won't destabilize that form, right? To destabilize that form, you need to do something that negotiates, let's say, resonates or deals with that same level of phenomena. Either you need to put so much water with so much pressure that like this creates a perturbation that is very drastic on the flow of water, or you need to change the shape of the drain, right? Or you need to put something there that interrupts it. But just, let's say, throwing water going the other direction until a certain limit, it won't really do much, right? And that guy was trying to think about the sort of transmission or sort of autonomy of constraints on one level from the bottom level. It seems like there is a relative autonomy of, for example, the form in the water over the constraints on the molecule, right? If you describe the behavior of the molecules, you won't describe anything going, say, spirally. You'll just describe things going, doing parts of that path more randomly than the form, right? More unstably than the form. And though they are starting from, let's say, outside the street and going into the drain, the form remains. So there is kind of a detachment, right?
Yeah. I think that's,
Go ahead.
I was going to say it's completely compatible with this view. I think we just need to consider this whole or this whirlpool to be part of this S, this big S. And then what you're calling adding more water to it is only affecting, let's say, the P part of it, right? So the behavior in S is preserved. And later on, they'll talk about this term compatibility.
Yeah.
Right. So adding more water is compatible with the whirlpool up to a certain point. Then the question is at what point or what things are required for the behavior part to no longer be compatible. And then you're talking about overriding that behavior now.
Yeah, I just thought that this was a sort of example that already implies that there is some level of freedom between subsets and behaviors, right?
Yes. Not like the bicycle and the wheel, but more like some dynamical form and then some part which supports that morphology, but isn't determining it, right?
I think a better example of this to think about is maybe something that where it's sort of easier to see what it does rather than what it is all the time. And I think maybe at least in a natural system, because before we even get to anything social, I think a good example of this could just be the climate, right? You can see things it does at certain points at like localized places around. And sure, even we as a society collect a ton of information. We get weather radar on the whole Earth and all these things, but there's still quite a lot that's missing and quite a lot that affects it because it's such a chaotic system that we just don't always know how to cut it up in terms of parts by its being, but we can see what it does in different places, right? We can see the effects of it.
Yeah, I like that example.
Can we also use quantum physics as an example of this, like the wave behavior of electrons? We cannot really substantialize the behavior, and if we substantialize, then we lose the behavior.
Yeah, I think quantum physics could be a good example just because we sort of still, I guess, as a society, have not found quote unquote the correct interpretation of what it actually means ontologically. What is the actual stuff? There's still a ton of debate among physicists and philosophers of physics. But we do know certain dynamical laws, right? Do show behaviors of certain kind between systems. So there is something.
Leverage. We are actually harnessing that behavior in order to achieve other things without knowing what is really what really underlies that behavior.
Sure. Yeah.
No, I think anything that has exhibits locality and behavior at the same time, right? Some set of behaviors and some notion of locality, you can apply this formalism to it.
Yeah, and to comment just on, I guess, this bottom part of the slide, to think about the right, when we think about objects and we're talking about mereology, we want to talk about parts, right? So when we have these behaviors on our sort of sheaves, so they're sort of built on top of these objects that exist or whatever is given. And then we talk about their parts as they factor through behavior. So this is the picture on the very bottom right. So the bottom left would just be two separate parts that maybe don't have a relation to each other. We don't know. This third one would be this little community diagram. You see there's the whole system that has behaviors of S that both factor to P and Q, these two subsets. But in order for Q to be a subset of P, in terms of its behaviors, the behaviors have to factor through in this way, right? So it's when you go from the full system to the smallest part, it's the same as going through the subpart. And that's how you define part-whole relations within the entire system. So it's already given some maybe relatively closed system that we can say exhibits some kind of behaviors, right?
So I have a question in terms of the whole part. In this case, whole part are not the constitution of the elements. So
no,
right. So it's like the whole is the behavior of the overall, and then part is the
maybe I can add a
so like
here,
weather
annotate.
system is really a good example for this. So you can have two different phenomena within an overall weather system. Like for example, wind and rain. Maybe that's not what it is, but so P and Q are not subsets or parts of S in terms of its constitution.
So they can be, but the point is that we're thinking of them as not by their being necessarily, but by them as behavior. So we see there's this S, P, and Q that I kind of drew on the outside, and we don't necessarily know. Like S is probably S is probably some big thing. S is probably some big thing out here. We don't really know P and Q. Maybe like it's possible that their sets don't really overlap at all, but that their behaviors, right? That certain things that S does completely restricts P and completely restricts Q. So the idea of S being the whole means that with S, you can fully describe the behaviors of P, which is this sheaf, right? These are actually could be functors, these guys, meaning that they take both objects and the arrows. So they also take the parts of P. So it shows how you can get what is this like category of parts of behaviors, behavior parts. So we think of everything as a part of something else as its behaviors. Yeah, I don't know if this makes sense.
Isn't a way to picture this surjective function as a partition on S? So because this was
this is exactly it. Yeah.
Mm-hmm.
Because then in this case, like I was trying to, you have like S. So is this the right way? And so you would have like all behaviors, and then a surjective would kind of like, so this you could say like is like the hand. So the hand, you would like collapse all behaviors into like maybe moving your hand to the right, like all the directions the hand could go.
Mm-hmm.
And so you indirectly like partition the space into like the point of like the resolution, the hand resolution, right?
Exactly.
All these behaviors become indistinguishable from this certain behavior of the hand.
Yeah,
then,
they become behaviors to the extent that they are behaviors of the hand, right? So any two behaviors where the hand behavior is the same are considered the same.
It sounds almost similar to the resolution boxes, right? These are,
yeah.
it also says it's a point of view. So if you could also restrict this more. So this could be like a finger, and then you can see even less, right? Like you would
Yeah.
lose more information, and then you would like have a even coarser partition. So
Yeah, that's a great
Yeah.
clarification, because
Yeah.
what we want to see with our mind's eye is an action. Let's say like running is an action. We want to see this running from different resolutions. So running from the perspective of the whole body, that's one picture. Running from the perspective of the hand, what does the hand see, let's say, when you're running? And then running from the perspective of the finger, what is the finger doing when you're running? So,
yeah, but I mean, just to be clear here, like, are we talking about partitions on S or BS?
This is really on BS, but you can think
Yeah,
of BS as a part of
BH,
S.
and BF,
Yeah.
right? I mean, just because, for example, the example that they give of an ecosystem, right, with foxes and rabbits, they are correlated. They're like in the Lotka-Volterra model, right? They're correlated, but they're not inside each other. So
no.
you can still have couplings of behavior. So the behavior of fox will depend on the behavior of the set of rabbits. So you can look at you can restrict it to one fox, but that doesn't imply inclusion on the system parts. It implies inclusion on the behavior part. Right? I think that's, I mean, inclusion partitions like that, but I think that's,
exactly.
That's,
so
yeah,
I know when
it's classes of movements, of hand movements, and not
classes of hand movements, not classes of elements
this is
of
what
the
Dennis
hand.
meant when he said before that this is like a quotient. It's a quotient of behaviors. A quotient means that you're taking, like this in this surjection picture, when you take these two elements on the top from the whole body and say in terms of their hand movement, they're the same, right? The hand does the same thing for both of these actions. Therefore, from the perspective of the hand, they're the same. So like in this whole picture, sorry, one more thing. In this whole picture, you see that the finger on the right is a part of the hand to the extent that every single action of the finger can be projected from some action of the hand, and that that map basically factors through the whole body through the hand as well, right? That's what it means for the hand to be, or for the finger to be a subset of the hand, that all of these behaviors factor through.
Yeah, and another way we could think of it is like the finger can't see more than the hand sees, right? The hand, although it sees something different, but it can't see more in the sense of like there's this loss of injectivity or one-to-oneness, right? But I was also going to say, because of just how the math works, the statement that Gabriel made about systems, they are actually inside of each other, but not in a
Extensional sense.
Intentional sense. It's more like logically they're inside of each other.
Yeah, exactly. That's my point. Like it's not extensionally. So doesn't imply that you have an extensional relation like you do have between body, hand, and finger, but that's accidental. You wouldn't need to have, let's say if you have someone else's finger, like body, hand, and someone else's finger, that would be as equally, if it's logically cohesive.
I think this perspective also, for example, if we're talking about hands and fingers and things, lends itself well to, for example, if you're thinking about maybe someone that has like a robotic hand or like a replacement, like a way that you can think of it as like a part of them. It is a part of them to the extent that things that they do and things that this new thing does is always restricted to one of their actions of their whole.
Yeah, or for example, if you take just, let's say, kind of weird kind of symbiotic relation between a parasite and a host, right?
That
it
too.
makes, yeah, you can say it's logically coupled, right? But you wouldn't say it's one thing is included in the other in the same sense as the rest of the matter of that host is part of it, right?
But isn't this analogy already taking us away from the whole purpose of Mereology, the body, and because these are all identifiable parts, whereas the whole point of studying these systems is because we don't, or we cannot, or we are not or this the Mereology is not about identification of or correlation of parts to the things that are
No, I think we're just trying to
behaving that
define.
way.
I think we're just trying to define more clearly that when you partition a system of behaviors into relevant behavior part, what is there any necessary correlation between logically distinguishable behavioral parts or types, right, and extensional sections of a system, or is that a looser relation?
That I understand, but by not corresponding them to constitutional characteristic, like what is a system constituted of in terms of underlying things. Like, for example, in a weather system, you don't, or in a stock market, you don't identify the parts that are, you correspond an overall behavior, and then you break down this behavior without understanding what constitution of that overall system, what the things that are included in those overall system are responsible for those behavior. So
yeah, but I think that's a different thing. Like, from what I understood, just correct me guys if I'm wrong, but it's a difference what I would call between a Kantian Mereology, which is saying I cannot know what X is. I do see effects of X and I can work with those, right? I cannot tell what the market is, but I know the effects on the financial market, something like this. But it's different to go a step further and say the thing is just those effects, right? The set of all of its effects exhausts its description. So I don't think, why am I saying this? Because, I mean, even if we don't need to avoid talking about bodies, hands, organs, because organs, hands, and bodies are logical units. Like, the very idea that they are more than that is already a mistake, right? I mean, ultimately, that's what, so you see my point, like you can do a Hegelian twist and pass on the fact that you only have access to the effects onto the being itself. So I don't think we should take this as a sort of, you analyze behavior when you cannot analyze the being. I think it's the inverse. It's the idea that you have a better analysis of the being by analyzing how its behaviors are structured. It's almost an equivalent.
Kind of ontologizing the actual behavior.
Yeah, so I think that's why I think that X is what X does is not a pragmatic statement. It's not like saying, we cannot tell what the noumenon is, so all we can do is see its behavior. I think it's a stronger statement that the two things are equivalent, right? That you capture the whole of the being by capturing not only, let's say, the list of its effects, but the ordering of its behavioral parts. Like, there is an equivalence between how the behaviors are ordered and the very ordering of the parts of the system, right?
Maybe we just leave it as a paralogism and continue.
Yeah, sure.
Yeah, I mean, it's interesting because I think that's baggage that philosophers bring to the table. But if you're just like trying to study the population of foxes and foxes and rabbits or whatever, then you're not even really caring about what is the being of what I'm studying per se. You're only working with these behavior sets or behavior types.
Yeah, exactly. It's about what can you get and what can you recover when you take this perspective.
Yeah.
Thinking about things.
So either way, like my question is that the diagram on the left says S, whereas the math is all about B of S. So,
yes.
So like I just wanted to understand what gives us the ability to jump from S on the side of the picture representation to the math that just is B of S. So
I think a good
in
example of that, you know what a good example would be to explain that? I think it's like dance choreography. Like imagine you go to a dance show. It's true you're seeing, you know that there is a sort of closure or sort of artificial stage, right? But you don't know what counts as a part, what counts as the whole yet, right?
Mhm.
The fact that there are 10 bodies on stage suggests that, okay, that 10 bodies form the system. But what is relevant? Like, is it talking about individual heads, arms, legs, or the fact that, you know, some legs always move together, like 3 people's legs are always moving together. And when they move together, something happens afterwards, right? Part of the whole point of what's happening there is making you see a set of kind of implications, right? A certain grammar for movement that is not the same, right? It's not intelligible from the perspective of individual dancers, but the sort of collective thing, right? So I think the whole point is to derive what counts as a whole and what counts as a part based on the implications, right? Those two operations that they propose, like what guarantees what, right? What allows for what and what ensures what, right?
Exactly. The logic comes first, and then the geometric intuition comes second.
Yeah,
So
I'm just trying to show maybe how we can maybe picture what Behavioural was talking about when we talk about like a dance performance, right? We can think of this as some sort of amorphous thing, right? Okay, so we can say that there's some people who are a part of the performance, right? But those people are also the dancers of the performance. They're actually doing the performance, even though we say that they are a part of it, right? And we could say that each person has certain possible behaviors. Sure, maybe in like in the extremely choreographed dance, it's all the possible behaviors are relatively rigid. But in something maybe like more improvisational, the set of behaviors can be much more open. It can be, I mean, I did like ballroom and Latin dancing, right? That's very improvisational. You can do one thing and then it's all about how you interact one with the other. So you can see how behaviors constrain one another. So I don't know. I think maybe it's a good way to picture it. So
Yeah,
like the dance moves are part of the dance also, but they are these like things which are sort of attached on top of the dancers in a way.
yeah, you can think of it as like the dancers are supporting a space that is not the visible space itself. It's something a little bigger than, or let's say it is still visible, but it's more than just the individual parts, right? I don't know if that added any clarity.
Yeah, I just think it's a good example, like very intuitively to talk about the fact that there are clear examples where you get the feeling that the space of behaviors is much more constrained and inner structured than the space of the system, like in the sense of you could take infinite possibly movements, like you could have a very, very, very loose improvisational thing that's totally unintelligible, right? Because people can move in infinite ways, but then you start seeing that if this happens and that happens, if this person moves, that person moves. So it creates a way of looking at how, let's say, what is allows for other things to happen, and how these things constrain other things that won't coincide with the system, right?
Or rather, it is the system.
Yeah, the
right?
dance system, right? Not the
dance system.
System of all movements the body can make.
Yes, that's the thing. The dance system is only constructed as a gluing of these parts. It's not something given ahead of time, right? But yeah, this topic is really deep, and it's kind of, I mean, this the whole point of topos theory is that you can have some kind of geometric or topological intuition that is supporting logic. And this is why Badiou chose this formalism, right? It's very
this
flexible.
whole discussion is almost the same as the discussion between the transcendental and the sets of the world, right?
Yeah, I think the interesting thing is with Badiou, at least our approach to Badiou, this whole time we've always started with assuming that the transcendental is accessible to us, right? But the nice thing about this behavioral thing is like we don't have access to the transcendental, meaning we don't know the shape of the system, but we have access to the behaviors, and then retroactively from the behaviors we construct the transcendental, which I think is actually much more practical view of Badiou.
Just a question I have. So is it one way to picture, like, so you have these different restrictions, right, which are defining different parts. So you could say like this I don't know, maybe you cannot see my mouse. So like this could be, say, the kinematics of the dance. So maybe just you can just only see like the directions of the bodies, and then you have coarser parts which say less and less. In this sense, you have full determination once you go to like coarser. But you could also have like different parts which are like the emotion of the dance, so like happy and sad movements. So the behavior Mereology also studies precisely kind of like the constraints, like what can, if you say like, if you see like a happy movement, what do you know about like the space of movements, of kinematic movements? It's something like that, like the way that different kind of like resolutions, different like point of views created by these parts relate between themselves, right? They have no like extensional relation. One is like emotions, the other are like movements, but you're able to relate them because they constrain in different ways through the system. Is that a way? Does that make sense?
Yeah, I think I see what you're saying, and I think we could maybe think of the big S as the thing that contains all possible ways of viewing the dance, or I don't know, all behaviors of the dance. So that includes the movement, but it also includes like maybe more abstract themes that, you know, evokes different emotions and so on. So that's big S. And then the P would be a subsystem that could be devoted towards emotions. And maybe that's actually not only the dance itself, but also the person, the observer is part of that system, right? And so you have what Yasha was calling factorization, which is in order for happiness to make sense, it needs to go through this system comprised of both the dancers and the observer, and maybe Q would be just the observer themselves.
Actually, I think this dance example is a particularly good one, or just performance in general that includes an audience is a good one.
Yeah.
Because I think the audience has like a more of a crucial role than we often give them credit for, where their reaction and like how the audience takes the art to whatever it is, if the performer can see it, like it constrains the performance itself in some way, right?
Yes, exactly.
So even though when we like normally would want to say the performance is just maybe the performer and the things that they're doing, but there's also the audience or whatever, the other context around it too.
So one question about the formalism on the last row. How do you read the morphism between the whole and part? Like, what do you say with that L, for example, LP and LQ designate?
Oh yeah, that's it's a weird thing, but it's not L, it's just a vertical bar that denotes restriction.
It's a restriction, yeah.
Okay.
You say it restricts.
Yeah. Restricts to P, right? So
yeah, restricts to P, restricts to Q.
Okay.
Yeah.
So it's a vertical bar. So that means that basically then formalizes the whole part relationship.
Yeah, it takes behaviors in the whole to behaviors in the part. Okay, so it's always in reference to some whole S, right? And then this diagram on the bottom shows the relation between how do you find out when there's some whole S and some part of a whole, which itself is also some whole P? How do their parts relate? So it's saying their parts relate in this way, that a part of P, which is this restriction Q, which is BP to BQ on the bottom, is going to be a part if it restricts through S in this way, right?
Yeah, you can write it like this, like Q equals. Oh well, the weird thing about this is that these two are named the same, but
yeah,
let's
they're
just say
technically different maps.
Yeah, let's put the S on this side. Oh, sorry, the S here. So it comes from S and it restricts to Q.
And then BLQ,
Yeah,
PLQ, sorry.
yeah. PLQ follows P or SLP, right? Not S bar P. I don't know. Right, so it's commutation, like it's a commutative diagram, like we've been talking about, right?
So this shows you how you can figure out from the parts of S, how you can figure out what parts of P are.
Yeah. Okay, so I think there's a lot more interesting stuff we could talk about in the next slide. So yeah, so we have this concept of spaces and parts that we attach to them, and behaviors. So now I'm kind of, in this slide, I kind of departed a little bit, although it's based on an idea from the text itself. So they define a constraint as a predicate on behaviors. And here's an example. So you have the behavior water, which can be constrained by the predicate is boiling to the behavior of boiling water, right? It's a very simple example. You have a bunch of behaviors that water is capable of, right? Everything that water is capable of. You want to only study boiling water. So you apply this predicate, apply a predicate to restrict, and actually that's not restriction, it's constraining, right? So that's really important. Restriction, let's just agree that restriction applies to the whole part relation, whereas constraining applies to predicates on behavior, right? Okay, and they give the suggestion that, and this is a common thing in different fields of science, that behaviors can be formalized as trajectories in some kind of space, like some manifold. Yeah, usually called like a phase space. So for now, let's assume that in this slide we have these BS and BP, right? If we want to look inside of these sets, what we'll find are actually trajectories in some kind of space. Okay, so we have behaviors of some part of a system, and then we're applying a predicate to these behaviors. So we're constraining them to some set of behaviors, some subset. So on the top left, we have water as such. On the right, we have water constrained to be boiling. On the bottom left, we have a different part. So let's say, I don't know, the pot itself. So if it's a pot of boiling water, a different part of it might be the metal handle, right? That has a relation, which this relation is like the restriction map that we saw here with this vertical bar. So imagine the vertical bar leads us down to the bottom left, and the constraint, which is a predicate, leads us from the left to the right. So what we want to understand is, how do we combine these two concepts? So we have a full language to describe not only constraints on behaviors and restrictions of behaviors, but also behaviors that are both constrained and restricted or related in some way, like relations between parts. So that's the point of this commutative diagram.
Yeah, it's about the relations between the constraints of parts, right? That's, I
Exactly.
guess, something what can be recovered.
Yeah. And I think that's the real contribution of this text, is that it gives us this a common language to connect these two ideas, so we can start mixing constraints and restrictions.
Yeah, and these so one more thing is that I guess this kind of connects to my original presentation from way long ago, that these constraints are really just maps from whatever the space of behaviors to either whatever you want to think of it, either 0, 1 or true, false, right? So just picking some out and then leaving the rest. And that's just a good way to think of it, because these maps to true and false are a thing that you see a lot. But
Yes.
a constraint is just a very general, doesn't have very many requirements on it, as long as it's consistent.
Right. Yeah. If you see here the drawing, some of these arrows look exactly the same on the left and right. That's because I left them intentionally the same to show that we're not changing these behaviors, we're just picking them out of the original space. Okay.
I understood the constraint. I didn't understand the restriction. Restriction is so constraint is you constrain the behavior, but the restriction, you constrain parts of the system. So one is the...
So a constraint is a predicate, is what a predicate does to a set of behaviors, right?
Oh.
A predicate constrains a set of behaviors by saying it is true for these behaviors and false for these behaviors, right? Okay. So for example, is boiling says it's true for water that's boiling, false for water that's not boiling. But it's just sort of the way that it's formalized. And then the interesting thing is how it goes through these parts. But the restriction of the parts is just describing how we can get parts from behaviors, right? We can say something as a part of something in the sense that it is all of its behaviors are fully determined by the behaviors of the whole.
Right. Yeah, the Mereology is happening here. There's no Mereology on the left, right? This is not, horizontally, there's no Mereology. I mean, at least at the top level, right? On the top, only from here to here, we get this picture from the previous slide, from BS to BP. That's this. Constraints are new, they're independent.
Yeah, this is just saying any predicate can be on I guess maybe one way to say it is a constraint is a predicate in context. It's a predicate plus a context for that predicate. So we're going to take some context as being the system, apply the predicate, and that's a constraint.
Is there a reverse of restriction? Is there in Mereology any way that you go from the behavior of the parts to the behavior of the whole?
Yes, and that's the next slide.
Yeah,
that's a good segue.
You did ask me before to ask this question.
Yeah, so. That's perfect
timing. Exactly. It shows how
great
coherent your
guy.
Yes. Actually, we're one slide early. No.
Yeah, we can mention it here though.
We'll mention it here. Yeah. So we talked about wholes and parts, but now we want to formalize this further and talk about relations between behaviors. So if you just imagine this, like there exists S in big S, imagine this little s as being a single one of these trajectories, right? The big S contains all of these things. So there exists S such that A restricted. So, okay, sorry, let me read this again. Behaviors A and B are compatible if and only if there exists a little s in big S such that little a is equal to little s restricted to a part, P, and little s restricted to Q is equal to B. Okay, what does that mean?
Yeah, I think I have a good explanation of this. So compatibility is basically saying that you have two behaviors that are behaviors of different parts of a system. For example, you say dancer A does this move and dancer B does some other move. These two moves, for example, which are behaviors, are going to be compatible if there's some behavior of the whole part of the whole system, in this case, the dance. So there is some possible movement of the dance so that both of them are it restricts to both of these, meaning that both of these behaviors are happening in this one behavior of the dance. So for example, like saying they're not hitting, like non-compatible behaviors would be if it would literally have one dancer like smacking the other in the face or something, right? As an example. Or
yeah, I had the impression that it was something like if you have somebody, let's say, throw somebody up, you can describe the movement of, you can decompose or partition the movement of throwing somebody up and picking them back up into the parts that concern one dancer and the other, right? So
yeah,
someone is going up and coming down.
Yeah, two behaviors are compatible if they can exist together, I think is the best way to think about it. If there's some place in which some behavior for the whole in which they both sub behaviors happen, right?
Yeah. So use the dance example. I think you could say like, what if this top green arrow is the waltz, and then the individual green arrow here is what person A doing the waltz is doing, and person B is doing, right? So two different dance partners, they each have their own moves, but together you can't do a waltz by yourself, so you need both of them to do this. So that those two things are compatible, and this is where the restriction condition comes in, right? S is the waltz. S restricted to P, which is a person, it gives you A, and S restricted to person Q gives you behavior B. So then we say A and B are compatible.
So for example, one person leading the dance and one person following the dance are ones that are compatible as long as they match up, right? As long as they're not stepping on each other's feet or whatever.
Yeah, and it gives you some freedom as well to like each individual person can do like different things that, but the whole thing still becomes the waltz.
Yeah. So for example, in the waltz, it's maybe more constrained, but if you want to take another dance example in something like a salsa, it's a little more open, right? Since it's more in the social context, and it's not choreographed exactly. It's not as like tight, close together.
Yeah, there's some flexibility.
Yeah, and you have this kind of scale of how disjoint are how compatible they are, right? So they can be fully disjoint, meaning that you have like a techno party where each one can do whatever they want. So any behavior are compatible with each other, and then you have
a choreographed waltz, right?
Yeah, exactly. Yeah. Where the compatible sets are really like small.
Exactly.
Yeah. This is where this language becomes useful, right? And actually even more is this next one, determination, right? So we say behavior A determines behavior B if for all, so notice that first one is there exists an S. This one says for all S, so for all behaviors in S restricted to P equals A implies that S restricted to Q is equal to B.
So this one I think is actually even a better example to think about, for example, the waltz, just because we already brought it up, because the behavior of the leader determines the behavior of the follower.
Yeah.
And that's kind of like how it's constructed, kind of very specifically. But the importance of determination, this is obviously a much stronger requirement. It's saying that any behavior is such that if it restricts to A, then it restricts to B, right?
Yeah, it's interesting because the waltz applies for both of these, but like you said, because the waltz is such a coordinated dance, what person A does will determine what person B does.
Yeah, so it's the waltz will have a very large set of I guess, like when you think of the set of behaviors between the two people, its set of behaviors that determine one another is going to be much larger than something like a techno party, right? Where anyone can do whatever they want as long as maybe they're not in each other's space,
Yeah,
not getting in fights.
exactly. So then, yeah, I think it's true then that if you determine something, then you are automatically compatible, but not the other way around. If you can be compatible but not determined, right?
Yes.
So techno party, you can be compatible, but you're not determining what the other person is doing.
Yeah,
Waltz,
as long as you have have some behavior, as long as you're doing something. Yeah, that's true.
Yeah. And then there's this little additional note that if A is a behavior of P and B is a behavior of Q, if Q is a part of P, meaning Q is a subsystem of P, then compatibility implies determination. Okay, that's a special case. So,
so for subparts, if two behaviors can exist together, the behavior of the bigger part completely determines the behavior of the smaller part. Right? That's basically what that means. So yeah, determination and compatibility are more interesting in the context of different parts, and you see that I guess the most interesting thing is that determination can actually completely recover the order of the parts.
I mean, just before we move along, like, what is it obvious, or do you guys see the connection between their notion of, their notion of compatibility and Badiou's notion of compatibility? Because they both seem to have to do with A and B being localizable from S, right? So if you have like this sort of minimal space S, and you can get from S to both A and to B, right? Then they are compatible.
yeah, let me just write Badiou's. A is compatible with B if the existence
of
A localized on B, right?
On B, and then the inverse, yeah,
is equal to
the existence of B on A.
Yeah. So yeah, I mean, definitely there's a connection here that behaviors are kind of like atoms, and localization is the same idea as in Badiou. The only thing is there's no such thing as existence per se, but it's essentially the same. Yeah, localizing there's like a topological intuition here. Yeah, but that's an interesting point. That
I'm trying to think. Yeah, because I mean, it even comes to a conclusion that is very similar, like that added point about a sort of direct ordering on subsystems P and Q, right? If you have that direct ordering, that let's say Q is a subsystem of P, that gives you some logic, right, in terms of compatibility and determination. So that's pretty much what Badiou calls real syntheses, right? If P is a territory for Q, right, it envelopes Q in the actual parts of the world, then you have some basic compatibility guaranteed between.
Yes, exactly. So what it means in this context for P to envelope Q is that the behaviors of P completely determine the behaviors of Q. Every single behavior of Q comes as a restriction from one of P that factors through the whole thing.
Yeah.
But I guess also one thing I wanted to mention is about this, how determination can recover the order of parts, which is sort of the interesting thing. there's a lemma in the paper, which it's one line, I'll read it to you. It just says a behavior always determines uniquely, which means that if you have A determines B, right? Meaning that there is some behavior of P, some behavior A and P, and some behavior B and Q, such that A determines B, and you also have A determining some other behavior B prime, also in P and also in Q, then B and B prime are the same, meaning that determination is unique. So
yeah, that's the atomic lemma.
Yes, exactly. Meaning that you can use this to basically find subsets by figuring out which behaviors of which things determine other things by like experimentation, right?
For example, if,
So
the person guiding the waltz does a movement and the person following does two different movements, but they both follow from the guide.
Exactly.
Those two movements fall under the same subset of possible responses to the guideline, right?
100%, exactly.
Yeah, that's the atomic behavior, yeah.
Yes. So that's in terms of how we can use, I guess, like experimentation to figure out what is this lattice structure of the whole in terms of behavior.
But the lattice structure is basically the lattice of partitions. So you have all possible partitions on BS, and then you have an order established by like coarse grains by inclusion, right? So,
yeah, you might throw away some partitions. Like you might not have all, like it's not like power set necessarily of, or not, power set's not the right word, but it's not necessarily all possible partitions that are valid.
You only get certain partitions, but each partition is a part.
Yes.
Yeah.
And what you recover is this poset like maybe chains of these regions of ordering between these parts, right? Or between partitions. Parts and partitions are the same, so I mean.
Yeah.
Okay.
So each partition, right, would have partitions within it, which are the parts of the parts. And as long as the behaviors factor in a way that respects this, then that's how you get the parts.
Yeah, this is
and
where I
atoms are important here. Yeah, just pointing out that the atoms are the limit to this partitioning process, right? At some point when you reach a single atomic behavior, whatever you're concerned about in that system, that smallest possible behavior, you cannot partition any further, right? So you have to choose the right atoms,
yeah, but that's what that lemma 10 is saying, right? That you have two, if there is a determination of A and B and a determination of A and B prime, then B and B prime are the same, right? You can't really differentiate them further, right?
Yeah,
it's if you can see things which are potentially parts, right? But you don't know their ordering necessarily, but you see parts of it and you want to know how the parts are related. You see how each of the parts behaves, and then you look at which behaviors determine other behaviors. So it's like a very experimental sort of way of looking at it.
Yeah, but I think like Gabriel's also adding that additional thing of like, let's say one of the dancers is breathing a certain way. Well, we might not be able to distinguish that breathing from the behavior of that move that they're performing at that moment, which is the atomic thing at this of this system.
Yeah, that's like the resolution.
Yeah, that's exactly. That's where resolutions appear again. Okay, cool. So yeah, I think we understand this part. So compatibility and determination are two types of relations that we can apply to behaviors, individual behaviors, right?
Yeah.
So
also, there just one quick thing. Compatibility, even though I guess we kind of seems like we smack talked it a little bit. It is actually useful where in actually constructing in the lattice of parts, what meets and joins, right? How do you do like a union and the intersection of different behavioral parts, right? And you
yeah,
basically do
yeah.
it by you disjoint union for example, for a meet. So if you want to do the intersection, essentially, what you do, you just take the disjoint union and then you factor, oh, sorry. Oh yeah. The meet, you take the disjoint union and you factor it by compatibility. And then the join, you do it from the product, and then you take a slice of the product such that they're compatible. But that's like not super important for what we're talking about. I just wanted to mention it.
I don't have it
But
open, but yeah. It's in the
are
paper.
are there two interpretations for what joining and meeting? This part I didn't understand. So are these just two ways of arriving at the same place, or are there like two?
It's how you can understand when behaviors intersect or combine together, right? So if you want to, it's just like this is generally often in math when you like give some new definition of like a category or a context. You have to sort of from the ground up show how everything works. So you want to show like how when you take two objects, if you combine them, or take their difference. So it's you get these two different operations, which are actually like inverses basically of one. Like one is like sort of like a limit, one is like a co-limit. So it's like the arrows are flipped in the category theory sense. Yeah, but it's just like
the meet would be the things that the two behaviors have in common, right? And the join would be
the difference.
Yeah, the difference. Yeah.
Mm-hmm.
Their difference in what sense?
You would move from them to the set of the two sets which have the things that they don't have in common, right?
No, I think maybe we have it backwards. Here's union, and it's all the compatible pairs, right? All compatible pairs of behaviors. So union excludes everything that's not compatible. And yeah, this one I was confused by, the intersection.
Okay. So I got it here. Okay, so the join, I can write down the definition if you want.
Oh, you don't see my screen. That's why I have the paper open this way.
Okay. I can write it, but it's going to be like this here. So if I take the behavior, so this is the meet. Oh,
can you still see?
Yeah.
Yeah, you see it. Yeah. So here the meet is on top. So it's when you take the behavior of the two sets and you quotient it by compatibility, which means that any two behaviors that are compatible that can exist together are considered as the same. So you're only thinking of the behaviors that exist differently. You're thinking of behaviors as they are like non-compatible, if that makes sense. So this is basically I guess the difference is the meet. This one, it's basically the difference. It's the intersection. And then the join is just going to be all of the set of compatible pairs. So it's any behaviors from P and any behaviors from Q that are compatible with each other. So this is like putting the two together. So meet is like an intersection, and then join is like a union.
So I mean, the union will be bigger in general than the intersection.
Yes, because it's all compatible parts. Where this is saying that any two things that are compatible are going to be the same. I just take the behaviors of P and the behaviors of Q in like one big basket, and then I glue together. So I take like BP or here, this is one basket, and I take BQ, BQ, another one, right? And these are inside some big thing. But then I am basically saying anytime they're compatible, I'm going to say they're the same thing. So really it's going to be this, I guess, these black sets where these are anything that are compatible. Does that make sense?
Yeah, but you don't throw them out, right? You still keep them.
Yeah, you keep them, but you glue them together. So they're made indistinguishable. That's what this
Right,
means,
right.
this
You
quotient.
count them, right? You count them only once.
It's like, yeah, you count them as one, essentially.
Right.
So
It's
two things are
exact-
compatible.
It's the same from chapter 1 in the 7 sketches where it's the same thing, right? Where you have partitions and then they can meet and join, and it's different.
Yes.
So in one case you get coarser, in the other case you get finer, right?
Mm-hmm. Yeah.
Of partition.
Exactly.
Yeah, this part I left out of the slides, but it's important. Because we actually, using this, I think we could form new parts, right? In a way. Given parts P and Q, we can form their join or meet. And that's actually another valid part of the system.
Yeah, they had a comment in the paper itself that said that for their purposes in general, the join is a more interesting thing to study. So sort of building from the ground up is easier than going from above and then going down, right? So the intersection is kind of going from the top down, and then the union or the join is going to be kind of from the ground up. So that's sort of also the atomic perspective. Yeah.
Okay, so we have compatibility determination, and we've seen things we can do with these. We can form these joins and meets with them. So what else can we do? Okay, so let's go directly to this. Okay, so we earlier we talked about these constraints, right? So let's look at this again. A constraint can be thought as a map from a behavior type to true false. This is another way of saying constraints are predicates, and because they're predicates, they kind of filter the sets of behaviors down to the ones we care about. So earlier I said like the difference between the behavior of water and the behavior of boiling water. Well, behavior of boiling water is just a subset in some sense of things that pass the test of is it boiling. So this can be formalized as a map. So on the left here, we have behaviors of P and behaviors of Q, and the restriction from P to Q. So Q is a part of P, right? But below here, we have this strange symbol, which is just the what's called the subobject classifier. But in our terminology of the primer and Badiou, we can think of it as the transcendental, right? This kind of allows us to classify all of our predicates as sub-objects of objects, right? So if you think of this map from BP to the subobject classifier, we're really thinking about all possible predicates in our space that can be applied to BP. And similarly, on the right, we're thinking about all possible predicates that can be applied to BQ. Now, in order to make this diagram commute, we're adding another condition, because it's not simply all predicates on part P and all predicates on part Q, but those predicates which are allow factorization through the restriction map, right? Through this commutative diagram that fall under the constraint of this commutative diagram. And this general idea is what is called constraint passing. We're passing, so this crazy formula on the left here, this one here, we're passing the constraint phi from Q, and it's odd because we're going backwards. We're applying it from Q back onto P. So this operator is a thing that you apply to a constraint to yield a new constraint, this time on the other part.
Yeah, so this is what's called the context changing functor.
Right.
It changes the context from constraints on P, which is on this left, from BP to omega. That's this thing, into constraints on Q here.
Actually, I thought it was reverse. It's because, isn't it psi, at least how it's written here, psi is.
Oh, sorry, yeah, Q to P, yeah, no, here, no, you're right, yeah.
No.
So it goes the other way, actually, in this picture.
Yeah, which I thought was
So
kind of
really,
confusing.
you would think of it like this. Get the same color. It's like an arrow. Oh, I'm still on this. It's like an arrow from there to there.
Mhm. It
That
goes
makes sense.
opposite of the
Mhm.
restriction.
Yeah. So this functor is taking these maps from these constraints on Q to the constraints on P to some part that they are contained within. So it changes context to something more general.
So it assumes that these parts are one determines the other, right? So it's not just two random parts. It's only
Yes.
okay.
Mm-hmm.
Sorry, say again. If you already have a relation of determination between P and Q, right? So they're already ordered with one being the subsystem of the other, then this holds. Is that it?
Yeah, here.
Yeah,
Q is a
we
part
don't-
of P.
Yeah, we don't need to use the word determination yet. We just say that one is a part of the other one,
Okay,
right?
okay.
Determination is a stronger condition.
Okay.
So Q you see on this right picture. Q is a part of P in the way that we described before with the behaviors. But if this is true, then all constraints on Q can be passed to constraints on P, which are going to be bigger and more general, right?
Yeah, because we're just saying that we're not defining added modality. If the constraint will be necessary or possible, right?
Yeah.
Yeah, so like imagine you're a fighter or a boxer, and because you're so good, you're able to fight somebody with one hand behind your back. So I think that could be like a constraint on Q called psi, right? You cannot use your right arm, for example. When you pass that constraint onto P, which is your entire body, you now need to consider like, how do I, defend against my opponent's blows using only one hand? But that requires not only your hand, but your entire body, right? Like you might use your feet or your other arm or something like that, right? So you're passing the constraint of your arm onto the constraint on the entire body.
Exactly. And so I guess this is a good way to introduce, right? So from this context changing functor, and this is based on what I mentioned before about Levier's work, noticing that this context changing functor in any topos has these two adjoints, which an adjoint is, you can think of it as like a half inverse. It's an inverse in one direction. So it has these two adjoints. We don't have to go too deep into the math of why exactly that's true. But it's existence and it's the two quantifiers, the existence and the universal quantifier, right? So it's saying that it goes the other way. It goes from the big part, from P to Q. It says for some constraint on P, you can say that there exists a P of Q for this constraint if there exists a P in BP. So there's a behavior on the full system such that it restricts, when it restricts to Q, it is this thing you put in, it is Q, and phi, whatever this constraint you put in here applies to P, to the whole subsystem. So it's saying that there exists some behavior that constrains correctly according to a constraint, right? Or either there exists one or every single behavior is going to go according to this constraint.
Yes. you're referring to these bottom two, bottom right two things, right? Yeah, exactly. You're the existence and the for all kind of show how this passing reflects back onto the part that was passed from, right? So you're saying like, yeah, there exists at least one behavior in the whole that will constrain to the part, and also there must also be some behaviors where all behaviors in P, if they restrict down to Q, they will determine that constrained behavior.
Yeah. So I think, for example,
dense,
if we go back to the dance example,
Mhm.
we can say that maybe some constraint can be maybe some like technical judgment of the quality of the dance or something, right? From maybe some relatively objective standpoint. And maybe it's about a specific behavior of a specific part of it, of Q. So maybe like the behavior of one of the dancers in particular. So you can say that there exists a behavior that is good, right, for this one dancer, if there is a behavior for the whole thing that restricts to it, and that there's basically it's possible, right, for this one dancer to do this amazing thing in the context of the entire dance, and for maybe like not everyone else to mess it up for them, and the quality of the other people has to be to a certain degree in order to maybe make the main part shine or whatever. So if there exists like some possible behavior for the whole thing, where the constraint actually applies somehow on the level of the whole rather than just on the level of the individual. I mean, because we always keep going back to it, ballroom dance is a great example of this, because if either the leader or the follower is not very good, then neither the full performance can't be good. But there is also a difference where it is sort of easier for, if there's a good leader rather than their good follower, for it to be okay, right? So this is maybe a way to show, I guess, an example of these existence and universal, because it shows how do we take something from that applies on the whole, and how do we talk about it on the level of the part. And it's whether there exists a behavior that factors through, or if there doesn't exist a behavior, or on the bottom example, if every single behavior.
Yeah. Just from a higher level, let's just consider that this triangle operator goes from the smaller part to the bigger part. So we're passing constraints from the smaller part to the bigger part. And then these two, their existent for all operators, they pass constraints from the bigger part to the smaller part. Two ways of passing from the bigger to the smaller, right? And they have this special relationship where if you have one of them, you pretty much, if you have this triangle one, then you can infer or produce a whole set of constraints from these other two, right? You get these other two for free, let's say, if you have the triangle one. And it's just, it logically works out because of the relation between there exists and for all, and how it corresponds to the determination here.
So it's, yeah, so I mean, these are a little bit confusing, because it's not just like an existence and a for all for one context, but for one part through another part, right? So it's saying, does there exist a behavior on the entire thing such that some constraint is true for a behavior on a part of it, right? Yeah. Or do we say that every single behavior of this part, of this kind, is such that there is its restriction, right, implies it's that restricting from P restricting to Q equals Q, this part originally. So if we can do this restriction this way, if it restricts, then it's going to be true automatically, right? So it's a way to talk about constraints on the difference between if something is true on the whole and if it's true on the part when we're talking about behaviors on the part, if that makes sense, maybe. It's a little bit confusing, but I think maybe it'll make sense.
So you start with the proposition on the bigger part, right, which is on P, and you see, so going from P to Q, you're going from bigger to small. So you start with a proposition on P and see how it, whether there exists or whether there is, it entails certain constraints on the smaller part, right? And whether
yes,
the triangle is, you're extending it back, you're seeing how once you already have your new like psi constraint, how it extends back to the bigger part. Is that right?
yeah. So the triangle is the context changing functor. So it says I have a behavior, or sorry, I have a constraint on a part. I'm gonna take it to what all the constraint on the entire whole, right? And this is going in reverse. It's saying there's some constraint phi, which I can define for the whole thing. And this is defining what it means for this this thing right here to hold. What this thing, you can think of this as a black box first, right? What does it mean for this to hold? It means that there is some behavior of the entire part, right? We're applying it to something in Q, to something in the part. So Q is in here, right? This is maybe some behavior. Oh, maybe this should actually be green. So Q is in here. It's whatever. You can think of it as a trajectory, right? And then in P, P here is going to be some behavior inside of here, right? But remember, there can be multiple of these, right? When they restrict, they send to Q, okay? So it's how I can say, I can put some kind of predicate on the entire space. It's describing how can I pass this predicate to the smaller space? How can I say it's true that there exists something such that this is true in the smaller space, or for everything in the smaller space, this is true? How can I say that in this context? I don't know if that makes sense.
Yeah, notice also the predicate here
Also, I'll be
shows
right
up,
back.
shows up again right here.
Yeah, but it's a bit confusing, right? Because in the first case, it's Q on the predicate, but it becomes P. So
That's why it's been passed. It's been passed from P to Q. So that's why we're defining the Q one. We don't know let's say we don't know the Q one. We only know the P one.
I see. Okay.
Start with the P one. So we're starting here, right? In P, BP. And now we're saying, oh, what happens to this proposition when we go to Q? Well, what happens to the proposition is the definition of this thing on the left. So we're defining the thing on the left in terms of the thing of the original 5P. So if the original 5P is boiling water, so that, okay, I have this system, and I'm saying, oh, the system is boiling. But I want to say what kind of constraint is necessary on, let's say, this part of the pot. What constraints can I put on this part of the pot? Then I pass through this existence one, right? There exists at least one behavior in the total system such that all this stuff holds, right? So it restricts to a behavior here, and where the boiling is holding. Okay, but yeah, that example is not great for seeing the usefulness of this. I think we still need to consider what examples. I think the Waltz might be more instructive, or something where there's like different moving parts, and you can see that.
Yeah. Okay. So I guess because we're still talking about the Waltz a lot, we have.
Yeah.
We're about the Waltz. That it's the whole. We can think about it as the two people dancing together, right? So that's going to be P in this case, right? So there's behaviors of the whole is going to be behaviors of this dance as two people dancing together, okay? We have some predicates that we can put on this space, right? We can say it was a good waltz, it was a bad waltz, it looked like this, it gave me this feeling, whatever, right? That you can apply to different waltzes. This is asking the question, how can I pass these predicates to the entire dance, which has two people in it, for example, to predicates of the behaviors of one of the people? So how can I say, for example, that the leader is doing a good job, or the follower looks so-and-so, right? So for example, the judges, or the judgment of the dance being good or bad is determined by certain expectations, certain roles for both of the partners, right? Like the follower is not going to be the one who is always leading all the movement, sort of by definition, in order for it to be a waltz. I don't know if that makes sense. So we can say that some quantifier, right, exists on, for example, the leader, right? If there's some behavior of the entire dance of them two together, such that this constraint, maybe the dance being good, applies to the entire dance, and that it restricts, meaning that the behavior, right, that is considered a good dance, when you actually look at what the leader was doing, it is actually that, right? It corresponds, right? So for example, if there's the greatest leader in the world, but then like a terrible follow, then there might not exist any situation if like the follower isn't good enough in which the dance looks good, right? That's an example.
Mhm.
Or if both of them are very good, then maybe for all situations it's going to look good because they're perfect and they always, are working on their craft, kind of thing.
Exactly. So we have kind of a weaker and a stronger variation of this constraint. The weaker variation would be like, okay, there must be at least one good dancer to execute this move, something like that, right? One good behavior to execute this, and the other one is like all behaviors are required to execute this move. Would that kind of approximate what you're saying, Yasha?
Yeah.
Okay, so but yeah, we definitely need to go back and like parse out this because it's a really dense formula. But yeah, I hope you guys are getting the big picture though, that like the triangle thing sends constraints from Q to P, and then the other ones send constraints from P to Q, and there's a weaker and a stronger one.
Right. Just as a really small question on the formalism. So because the existential and for all quantifiers, they go from P to Q. But why is it that the domain of the existential is Q? Like to me, it reads that like you input a Q inside the existential, and then you end up in the piece that exists and satisfies the constraint. So I think I'm reading it wrong.
Yeah, so the inputs to this are actually not behaviors, but they are predicates.
Oh, okay.
So this one takes in a predicate like this phi here, and it spits out this whole thing.
But this Q, this small Q is given, or is it?
Yeah, small q is what is inside the BQ. So this is small, sorry, I wrote P here, but small q is inside of BQ.
Yeah. Remember that this notation, this like exponent notation in category theory means the maps, it's all functions from BQ, from behaviors to here omega, right? Which if we're just saying is can be for predicates, it can just be true or false, or if you want to go into like a more Heyting algebra sort of intuitionistic logic way, you could do that too. Anything but do, but
Okay.
this is maps from BQ. So these are propositions. Or
I'm definitely lagging behind on understanding this. I'll try to, don't want to like delay the presentation too much, but for example, I don't understand the relation between the phi, because there is this predicate here, and there's this predicate here. They're different, right? And they have the thing that, well, if this triple adjoint thing is valid, then they say that this thing here entails this, right?
No. Sorry, I just wrote a different character on the left, but it has no relation to the one on the right.
You're sure? Because they distinguish those things.
I mean, well,
In the
okay,
paper.
so they're
Yeah,
both going to be
they're not the same.
Yeah.
They're different.
Oh yes, there is an entail, but that's in a later slide, I think. we haven't talked about entailing yet. But you're right, yeah. I just didn't make that connection about
No,
entailing.
because for me, yeah, that changes everything, right? The fact that these two are defined on this, I forgot. This is what did it say? Like
it's phi, yeah.
And this is also phi.
This is psi.
Psi, yeah. So these are defined on phi. So it's another predicate, and this is the predicate you're passing, right?
No. The original phi is the predicate we started with, and then the operator creates a new phi, but it's
okay.
called
so this
there
is the
exists.
Yeah, okay. So this is the original one.
Yeah, this one on the over here that I'm circling becomes this one.
I see.
And then
so the
here,
starting one is the
this
phi.
one becomes this one.
Yeah. But when you actually think of this operator, this operator delta itself, you think of it like this, as like it's a functor between this category and this category, right? So it takes the objects, which are these, and maps between the objects, which would be how these factor. Yeah, but the important part is that it's and Levier showed this before, I mentioned this before, but in any topos, you have between parts this context changing functor, right? You have a way of how do you pass predicates from one part to another. This is defined in a certain way, and it's two adjoints, and these are universal adjoints, are these existential and universal quantifiers with respect from the whole to the part. And the reason why you get these two of them is because there's some ambiguity, because remember, this restriction is basically a quotient. You're taking a bunch of behaviors in the whole thing, and you're thinking of them as the same in the part, in the sense that their behavior in the part would be the same, right? So this is describing how do you go from the whole to the part to the whole and the whole to the part. So the context changing is going sort of like bigger. So you say, I have these constraints here. What do constraints on the part? If I say in the dance example, this dancer's doing this well or this badly or whatever, what does that mean about the whole? And how does it fit into the whole? And it gives some certain constraints to the whole. It doesn't determine it completely, but gives some it says something about the whole. Then the existential and universal quantifiers, these are going the opposite way. They're saying,
Are you drawing it, Yasha?
no.
I was just trying my pen, see if it would work.
No.
Sorry.
But these existential and universal quantifiers are going the opposite way. They're saying, well, I know something about the whole. I know maybe like what predicates are on the whole. I can say things about the whole thing, but I want to understand the structure of the part. If there exists certain behaviors on the part that determine something for the whole, or if for every behavior on this part, something is true for the whole, right? I don't know if that makes any more sense.
Maybe another angle we could approach is like through observation. Like when predicates can be thought of as like observations, and maybe when we look at I don't know, like a couple dancing, we can say like they are waltzing. So we've defined a predicate on this couple, and they may or may not be satisfying that predicate, right? They are waltzing. And then we're passing to one of the persons of the couple. And now we're saying, what happens to that predicate, they are waltzing? Well, we can't just say she is waltzing or he is waltzing, because that maybe doesn't make sense for an individual. So we need to create let's say a special new predicate, but it still has a relation to the original, they are waltzing, right? And there's two ways of doing that. There's the existential or way, like the weaker way. There is at least one thing, one behavior that satisfies, and then there's the stronger one, which is like all behaviors of the whole are at play in the waltzing. I don't know, but I think we should move on and
I
come
agree.
back to this slide later. Because I think also the paper is better at describing these. This is a really condensed version of that of the chapter. Okay, so assuming we have this capacity to pass constraints around, this is where we get into two new kind of operators, right? So we've defined these three operators, the context change, the existence, and the for all. But the ones that the paper is really interested in is allows and ensures. And they are defined basically through this diagram. So if you follow the arrows from BP on the left here, from BP all the way to BQ, you have a composition happening, right? You're doing the context change, and then you're doing the existence. And on the right, you're doing the context change, and you're doing the for all. So the same way that earlier we said there's these two things that you got, right? The delta or the triangle. The triangle gives us the existence and the for all. Well, now that implies for two parts of S, we have two paths to get to Q. We can take the triangle, which always goes from a smaller part to a bigger part. We can take the triangle and then take the existence route, or we can take the triangle and go through the for all route. And if we take the existence route, which is the second part of the second leg of this route, we're creating a operator called allows. If we take the stronger route or the for all route, then we're doing ensures. And these routes or whatever, they're just ways of taking constraints from our starting point and turning them into new constraints at the end point. So
and they are very, very closely related to the difference between compatibility and determination.
exactly.
Allows is just guarantees compatibility, right?
Yeah, exactly. Allows saying there's at least one thing that's allowing this to happen, but it doesn't force everything to follow that.
Yeah.
Allowing
So
is saying that if a certain property holds, then another property can hold together, but doesn't mean that it
yes.
does hold, right?
Exactly.
Yeah. The important thing is that here now, so before P and Q were subsets of one another in the previous some of the previous slides. Here, P and Q are completely different subsets. They're parts of some system. So it's saying, how can I understand how constraints on P and constraints on Q are related to each other, right? So first you go from P, if you want to go from P to Q, you can, by allowance and insurance, you can get it by either by first context changing to the whole behavior and then quantifying down, right? Because remember, the quantification happens from the whole to the part, and the context change goes from the part to the whole.
This one.
Yeah, but here basically this line is the important thing. So it formalizes these two. Insurance is that there is some behavior on Q that exists with the behavior on P that like they can happen together, right? And insurance is allowance, and insurance is like determination in that way, but for constraints.
Yeah, could we, I mean, this seems to be really the core of the whole thing, that you can suddenly start having a language to talk about, again, passing constraints without this sort of superposition between constraint logic or behavior logic and the sort of system subsystem relation, right? Now you can have Q and P both belong to, both they're enveloped by S, right? But it doesn't mean that they are one included in the other.
Yeah.
And you can still preserve the constraint passing relation. So that, I mean, that seems to be the big part, the big interesting thing, right?
Yeah.
But so just to recap from that perspective, that this is possible ultimately. The previous step was under stricter conditions, right? The triple adjoint thing we were looking at, it was very complicated. It's restricted to the case where Q is part of P, right? Q is smaller than P, right?
Yes. And but they are here. We just didn't draw them on this diagram. But technically, there is this one and there's this one, right?
Yeah. From what I understood. Oh, sorry.
And then there's this one as well, right?
So what's happening is we're passing through the whole in order to relate a behavior Q on Q, right, to some constraint phi on P, okay? So I'm trying to say that allowance is going to be that I say that phi allows Q, this is true, right? It looks like this. It's going to be P, Q, and then phi of Q, right? So this is when I actually apply it to something. Q, this. Q is a behavior of Q, right? Phi is something that applies to P, to the behaviors on P. So it's saying that there is going to be some behavior on P that can happen while this other thing is true on some behavior of Q that can happen while this other thing is true on P. So for example, I can say one dancer allows the other one, or for example, the leader allows the follower to like look good and flourish, because often the point of the leader is to be there to make the follower look better, right? So you can say that an action of the leader allows this constraint, which is like the follower, whatever, their path and their dance, their part of the dance to look good. Their action allows it if they can be doing that action, they could be doing whatever their I guess techniques they have while the follower looks good. It doesn't prevent the follower from looking bad, right? Or if I guess insurance maybe here it doesn't quite apply as much, because the follower will have some of her own agency, right? So there's not going to be very much that the leader completely ensures for the follower. But there may be certain things that if he is good enough, then it ensures that she at least won't look terrible, right?
Yeah, like you can ensure that your partner doesn't fall on the floor by catching.
Exactly. Yeah.
By catching her.
Or it doesn't hit other people if there's other people on the floor. So it's taking the previous slide, which the previous slide was relating constraints between parts and wholes, and how the constraints pass between parts and wholes in different directions. And this is now going between two different parts by going through the entire thing. So this is really where the Mereology is happening, right? There's some big system S, and we're saying, how do behaviors of one part restrict predicates on another part? Does that make sense?
Well, yeah. So it's like you could interpret phi as like, is a certain move dance move in like partner A will it happen? And then you can like the partner B can maybe do something, like he can do something that opens up the possibility of that move being done. So there could be stuff that would completely close up a certain move to be done.
Exactly.
So that allows, but you could like partner B could also throw up the player A, and in that case it ensures.
Oh yeah, I guess in that case the bad things definitely ensure certain things, right? If the leader smashes the girl into someone else, then that ensures the dance is going to look bad, right?
Right, but yeah. But the contrary, you could also like he throws in the air, and now it ensures that dancer A will have to do a certain like
sure
like flying move.
Yeah, or like if you think about like a game like chess, there are certain moves where you allow your opponent to respond in many different ways, but there are also certain forcing moves or certain combinations where your opponent has to like protect their king or something like that. So this is nice, because now we're kind of letting these constraints circulate across the body. And if we go back to the idea at the beginning where I was saying cyber physical systems, right? We're talking about some mediation with machines, maybe software, and we can encode rules so that in order for one group of people somewhere to have a certain property, you must have a certain behavior in another group of people somewhere else, right? And mediated by this kind of, let's say, like a online interface. And then you have these two variations of allowing and ensuring, right? So we can start to like craft a language that you give it the constraints, and it will automatically give you the associated constraints on the other parts, right? For every constraint phi that you put into the system will automatically know how to create an allowance version and an insurance version of that constraint for every other part.
Yeah, I just want to add that compatibility and determination, what we were talking about before, are actually special cases of these allowance and insurance operators. So compatibility is actually the allowance of equality, and then insurance is going to be, determination is going to be the insurance of equality. Let me just make sure I write this down correctly. P and Q, and this is going to be also equals Q P. Right. So two behaviors are going to be compatible if the allowance of the equality of P, meaning that it is possible that if there's this behavior can happen while it's equal to P, then those two behaviors will be compatible, meaning that basically they're compatible if there is some behavior where they both can happen, right? Because they would be equal in terms of the entire thing here. And determination is specific, and also in a similar way. But I don't know if we need to get into that. It's just interesting that this actually generalizes compatibility and determination, what we were talking about before, right? So we can recover the order of the parts and everything using this.
Okay, yeah, that's a good point, because now we don't need the restriction condition. We can just use this operator directly. But it's like two ways of kind of saying the same thing, right?
Yeah.
Sorry, sorry. Can you go back? Like, it's the what is the same? Allowance and insurance are the same. Are they more general than?
They're more general, right?
Yeah.
So what is the condition that it has been loosened? Which is that?
So yeah. Compatibility is allowance on equality of P, right? So it's saying that two things are compatible. Yeah, okay, I'll explain. Yeah, two things are compatible if there is a behavior on the whole where these two things are indistinguishable, meaning in the sense that there's a behavior where they both exist.
Yeah.
It's a little bit like a tautology. It's kind of like when you do it this way, it's going from the other direction, right? So if you sort of have both, it's like it can become circular.
Yeah, I think another thing to add is compatibility is a relation between behaviors, but the thing on the right is something that acts on constraints. So they're kind of acting on two different categories or two different ways of seeing. It's the same idea, but one applies to constraints and one applies to behaviors.
Here, the constraint is equality with P in the bigger context, right? Or equality with Q in the bigger context.
Let's see.
Yes, I see. Yeah, so equal P means like they're indistinguishable in the bigger context, right?
Yeah, exactly. So that's the constraint in this case. So that's how it's a special case. If the constraint is just equality in the bigger context, then you recover compatibility and determination.
Okay. Then the final slide. Okay, we finally get to this entailing thing, and we're basically saying that there's this new operator, not operator, but this symbol entails, which says it basically means if the first predicate holds, then the second must hold, right? Then we say this is there's an entailment relation. And with this entailment relation, we can now define composition. So everything in category theory is a map. So you're kind of talking about these operators as maps, right? Actually, that was the implicit thing here, right? When we compose the arrow of the triangle with the arrow of there exists, we created a new arrow, right? This new arrow is called this thing, right? This diamond shaped thing. That's a new arrow. And similarly, we created a new arrow, the insurance. So the first one is allowance.
Between different parts.
Between different parts, right? So
yeah.
This one goes from P to Q, but they both go from P to Q, but in two different ways. So now that we have these arrows, we want to talk about composition, or what is the law of composition here? And these are the two rules. So when we allow something from P to R, this entails that we're allowing something from Q to R and something from P to Q. So actually you read it right to left because of the category theory convention, but it makes things confusing. But yeah, P to Q to R, these are the parts, right? P to Q, Q to R. So if P allowed something in R, that means P allowed something in Q, which allowed something in R.
Mm-hmm.
So if my left hand allowed something in my right hand, that means my left hand allowed something in, let's say, my arm or my body in general, and that allowed something in R.
So the important thing about these two relations here is it shows the difference between allowance and insurance, right? So allowance says that if I have something on the whole, and I have some part sort of like in between, there's gonna be some way that it factors through the part if it allows on the whole, right? It's gonna have to exist. The insurance, right here, what this rule is saying, and it's basically like an elimination rule that you're used to in logic. But it's saying that if I have an insurance between two parts, sort of on the sub level, right? I have like A implies B, B implies C, then it's like transitive. I get the implication on the whole thing. So it's a little stronger. Insurance sort of like, I guess, builds from the ground up, and then allowance, you can go in the reverse. So it's stronger to do insurance in the same way that's stronger to do determination, right? Since insurance is a more general version of determination, like we were talking about.
Yeah. In determination, you can think of it as like if A determines B, and let's say there's something in between, like C, right? Mm-hmm. A determining B does not let you, you cannot entail from that A determines C and C determined B, right? It might have been that A made something compatible, it allowed something in C, which then determined B. So there's a certain within insurance, you cannot draw that much from looking at the allowance of. Let's do it this way. I think putting C at the end makes more sense. If I know that A is insuring something on C, right? You can think of this as a relation in the Badiouian sense, right? A is insuring something on C. Well, we know that both A and B have a relation, or A and C have a relation to B, right? Mm-hmm. But simply knowing that A insures on C does not mean that this holds. But the opposite is true. If we know A insures B and B insures C, then we can say that the top thing is an insurance. So if we play this game of labeling these relations, we can if we know that the bottom two arrows are squares, then the top one must be a square. But we cannot infer that if the top one is a square, the bottom two are squares. But it's the exact opposite with the diamond shape. The diamond shape is, if we know that the top one is a diamond, we can automatically infer that these two are diamonds.
Or that they exist, right? That both of them exist.
That they exist.
Yeah.
Okay. And then there's a special case, but we can skip that. That's just the case where one is the part of the other one. Then these become the regular operators again. There exists and for all. So in that sense, these diamond and square shape operators, or the allowance and the insurance operators, are generalizations of the there exists and the for all.
Yeah, there's some, I guess, some things I can add about the allowance and insurance, specifically about how they relate to some logical things. Like for example, the allowance will commute with both the or operator and the exists operator, which if that makes sense, because it's going from the bigger context to this, it can go from the bigger to the smaller. And insurance in the opposite. Insurance will commute with the and the for all operator as well. Just a thing to add, that there's like a relation to the logic. So using this stuff, you should be able to like recover some sort of, it's sort of like, I guess, a little bit of a, not a recipe, but the beginning, maybe like the building blocks of how to construct a logic of behaviors and what behaviors determine what for other behaviors.
Right. So yeah, you're talking about how we can build new constraints out of old constraints using and or, right? So if we do like this is actually equal to a new constraint. And so like the water is boiling and the water is, I don't know, in a vortex. Versus the water is boiling or the water is in a vortex.
Yeah, right? So it's saying that this basically is going to be equal to, and I'm leaving out the P's and the Q's, fee and allowance on this one. Sorry, that looks ugly. And this one works for insurance. Oh shoot, did I do that the other way around? Yeah, I did the other. Yeah, this should be a square. A square is insurance. And the allowance is the diamond. And for the diamond works with the or. The same way. Diamond of fee or diamond. Sorry, it's ugly. Sorry. Yeah, so it's just getting basically like the basic logical operators and making sure things work.
Yeah, and that's like, yeah, it's a nice application of the whole like left adjoints preserve colimits and right adjoints preserve limits or something. Okay, then the last step here is there's just a note at the end about, so we have these, they're called modalities because they're derived from the Kripke thing of like, it is necessary and it is possible, right? There's actually a relation between Kripke's operators and possible, the whole many worlds semantics and this bodily or mereological modalities. And it's basically, I forgot what I wrote here, that okay, yeah, if you come up with a behavior type of one element, if you factor through this behavior type of one element, so a single behavior, then given the constraint phi, we yeah, when you compose this way, you recover the possibility and the necessary.
Yeah, so the idea here, I think, is that if you constrain sort of like through the atoms, then you get possibility and necessity in general. So sort of like if you constrain, or if you look at this, so we want to say, is it possible that phi for some part, phi for whatever predicate phi is? It's saying that if I go all the way to the base level that you can look to the atoms of that situation, if you want to know the possibility for all of P, if phi is possible, right? Just in general, when the behaviors are thought of as a set of all possible behaviors, right? It's all of the things that possibly could happen for any situation. It's a very large set. This is how you can recover possibility in general, by going down to the atoms, and the same for necessity. And if you want the exact, maybe, I guess, math justification, you might have to ask Spivak and them, because I think they actually in this part, it refers to something else in the literature that I don't completely understand about Kripke frames and things, but.
Yeah, I don't know. Yeah, but it's handy for us to, if we want to like, if we want to, translate, because a lot of maybe rules, we can write rules as in terms of like, it is necessary that this is true, or it is possible that this is true, and then we could translate that into this intermodalities.
Yeah,
with this rule.
Exactly. So you can think of this bottom operator, this thing, as the intersection of all of the parts, right? It's like the empty set for that system, whatever that means. What is in common between everything?
Oh, is that okay? So you're saying because we're going to the singleton.
It's so
So
it's the single, so it's the bottom element, right, of the entire poset of behavior parts. So it's going to be the part that is common to everything in terms of behaviors.
On the previous, so because this allowing and ensuring, they're really like broad and weak relations, right? So it's on one hand, it's broader than determination, because determination is a relation between behaviors, and while the insurance allowance is mediated by the predicate, right? Which is something binary. And it's also broader than the for all and the existence, because for all and existence are relation between parts and wholes, right?
Yes.
So it's something that can relate parts and wholes, and via a predicate, is it something like, can I picture it as like a partition of two partition of two parts, in which like you kind of like lose information of the part and then trying to regain it in some sense. So it's like you have a partition that defines a part, and then when you pass by this predicate, you kind of like just focus on a certain aspect of the score screen, right, of this partition, and then you look projected back into a part. Is that a way to say it?
Yeah, I mean, so how I was thinking about it was it's relating predicates on one part and behaviors on another part. It's saying which behaviors on this part are compatible with a predicate on another part.
Yeah, if we go back to this diagram, I think this is what I was trying to get at. This question mark is where the intermodalities come in, because we know how to get from behaviors from a whole to a part. Oh, it's not, sorry. Behaviors to a constrained predicate version of behaviors, right? That's going from left to right. And we know how to get from whole to part, which is going up and down. Intermodalities let us go both ways. So we can jump from the body to an organ and from like the constraint of the organ back to the constraint of another organ, let's say.
Yeah, I think that's about right. I don't know if that answered your question, Renzo.
Yeah, I'm not sure.
I forgot exactly what it was at this point.
Yeah, so because it's something I'm trying to understand why in which ways it's broader than compatibility and determination, because compatibility is also, you can also relate parts. You can also relate a part with another part, right? And it seems that it's broader because the predicate.
Well, compatibility doesn't relate the whole parts, it relates behaviors on the parts, right? So compatibility and determination are relations between behaviors of two different parts. One behavior on one part is compatible with a behavior on another part if there's some behavior on the whole thing in which they both can happen at the same time. And determination is when every single time one behavior happens, the other behavior happens, right? So it's more general in the sense that rather than relating a part and a part, it's relating a predicate and a part. But the thing is, the predicate, by having the predicate equality, meaning anything that is equal to P, right? By using that predicate, you can actually recover the original compatibility and determination. Does that make sense?
Yeah, I think what's tricky here is the difference between behaviors and constraints, because it seems kind of like a behavior, like if we say the original example of boiling water, well, on the one hand, it's a constraint on the behavior of water. Boiling is a constraint, but on the other hand, you could say, well, isn't it just another behavior? Isn't boiling just a behavior of water? But I think if we clarify that point, it makes sense.
I feel like they shouldn't have used, I'm not sure if I'm wrong, but I have the impression they shouldn't have used predicates, but functions. I mean, it seems like it's interchangeable, what they call a predicate function.
Well, no, a predicate is a type of function, right? It's a function that takes things to true and false. It picks things out. It says the predicate is true for these things and false for these things.
Yeah. And I think the effect here is that you want to build higher order concepts on top of behaviors. So it's really relative to what you choose as your atoms, right? You choose certain atoms, which are your behaviors. But then on top of that, you can take a group of these behaviors and call that a constraint. But it's not set in stone which are the behaviors. The original, you have some choice there, I think.
No, the point that I wanted to make is just that sometimes it's a bit mixed up for me, the analytical part of this paper, in the sense of a way to analyze the relation between behaviors, right? And a sort of more structural synthetic point of view, where the fact that certain things are coupled in certain ways, actually, let's say, defining what it is, right? Sometimes I get a bit confused with like if the point of the paper is to give us a rigorous way to talk about a richer way of talking about how parts of a system determine other parts, right? And then you have like weak determination, compatibility. It's like an allows for, but doesn't guarantee. And then a stronger determination but it's not a mechanistic thing because you can have a very rich kind of entailment structure. It's not only either weak or strong, but it's also it can have a very weird topology. It doesn't need to be simply like mechanistic things where, you know, prior things affect the next things. You define them all by a sort of particle kind of state structure. You can have more interesting things than simply talking about particles affecting particles, right? So it seems to me like most of the interesting thing is just showing that it is rigorous. It's still it is rationally definable to talk about things interacting with things in such a loose way, right?
Yeah, I think it shows that you can recover a sort of logic of what things do based on how you observe the actions of parts and how they relate to the actions, right, of each other, right? So for example, we can recover the ordering of the parts by determination. What does that mean? We can see what behaviors lead to other behaviors. And if one thing, when it does something, always leads to some other thing doing something else, we can determine that the one is like determines the other, that everything that the second one does, if every single one of its actions is caused by one of the actions of the other part, then we can say that the first part is a subset, is not a subset, a superset is bigger than the whole thing if one determines the other.
Mm-hmm.
Yeah,
I don't know.
I think,
so
yeah,
we can, so by recovering the order, we can recover the logic also.
Mhm.
And that's the point of this whole passing constraints thing at the end.
yeah, it is very analytic. Right?
Yeah.
It is about taking some things you're seeing or observing and then deducing all possible statements that can be derived from. But you have to make assumptions of what is part of a system, I guess. I guess actually, you don't.
Yeah, the weird thing for me, I mean, and I think this is the reason why they leave the discussion about what is a thing we need to leave out, because I think they go as far as talking about a language to split up dynamical systems in terms of their components. Like when I was reading this paper, I even scanned a bit of the text here to share with you guys. Not sure if you have Robert Rose's book, but like ultimately, I think that they should have given a name. You know, they have this sort of behavioral parts. Okay, it's parts that display some behavior under a certain correlation or interaction with other parts, right? So it seems to me like they show that you can actually redescribe dynamic interaction, so on, from the standpoint simply of things that relate to others in terms of the constraints. So, and that doesn't mean you're creating a coarse-grained vision. And exactly as you guys said, the really cool thing is that you can recuperate the sort of intrinsic description from the description of these behavioral components, right? It's not, that's the point that Reza was making that I was kind of arguing against. It's not really simply saying you cannot know the thing, but you can know a bit how it behaves. It's actually, no, knowing how it behaves here is exhausting what it is, or potentially exhaust what it is, right? It is not a weaker way of describing. So that sounds a lot like showing that it is coherent to talk about dynamical systems, not in terms of the states that it is, but in terms of this behavioral logic of the system, which might disregard or not fully coincide with a sort of phase space of, you know, its variations, right?
Yeah.
Mhm.
And this in general, I think it fits the Yoneda standpoint, which is like, you don't ever really know what a thing is. You only know its interactions with its all the other things, right, in your category. So you want to know what the brain is doing. Well, the best way to do that is to like an IIT, you're sending pulses and seeing how the brain responds, right? So you're capturing the behavior through, but the behavior when you connected the brain to another system, which is your electrical system, right? Some external signal. So what a thing is the sum of its relations, of the ways you can probe into it. So in that sense, every system is open for that kind of probing. And the constraints are just a way to organize that data. So you have the brain and you're shocking the brain or whatever in many different ways, and you're recording that information. These constraints allow you to organize that data in such a way that it starts to become a coherent logical place for, like, you can make inferences now, because you can say like, this part, when I shocked it this way, this part reacted this way, but then this other part reacted a different way, and then I did it this other way, and now like the relations were reversed or something, I don't know. And now that data starts to make sense and you can make inferences. I think, yeah, the entailing thing is really important, but we didn't.
But this is what I wanted to get at. Like, I have the I'm not sure what you guys think, but I have the impression that that they go in the direction of establishing a good approach to a problem, which is this sort of constraint or behavioral approach, and they do the applied category theory shtick, which is great. I love it, which is to say, look, you can derive the sort of parts and wholes structure. They're going to be derived from the behavioral logic, right? What counts as the whole and the parts are actually context-based to the behaviors. So, and they show that this holds and that it's not simply how do you say it, like a poorer description of a system, but you can actually recuperate the relation between the ordering of the subsystems from this way of describing it, right? Okay, so when we stop there, what do we have? I think that, for example, going back to our project, right? I don't think we have enough to talk about organizations, for example, because you would need to talk about the architecture of constraints to talk about organizations, for example, right? For example, why is a choreography different from, let's say, being told by somebody on the bus stop, everyone stops because the bus is arriving? It's a coordinated movement, right? But there is something about the constraints that are not closed to that set, right? It's actually dependent on the traffic, which is dependent on the city, which is dependent on a bunch of stuff, right? Whereas there's something about choreography which is weirdly self-contained. It's clearly opened as a physical system, right? But it's weirdly closed in a different way.
Yeah.
And I think that, I mean, this is why I say I think it stops at some point. And then they wanted to go as far as talking about things, and like say moving from the sort of atomic description of behaviors to the object, right? And I feel like, okay, I kind of get the feeling that I understand how to compose statements about behavioral parts of a system and so on, but for now it's very arbitrary. I mean, it's very top down. So the decision of what is a system and what is the behavioral system is actually always arbitrary and given, right? Which ultimately is not something you want. You want to find out what is the system from the constraints as well, right? The fact that something does not entail some other constraint somewhere else, for example, might mean that it is a closed or at least separable system, right? For now, it seems to me that in this text, the BS, which is a very aptly named set of behaviors, it is a bit, it's playing multiple functions. Like it's too loosely determined by its parts, when it should be almost exhaustible by its parts, right? Does it make sense to you guys? Like,
yeah, I do think the set of behaviors, right, often for many things is a much larger set than you can like actually deal with, right? So like while you could like construct this thing, it might not be like maybe like something computable or something that you can actually like formalize in the computer to make you do something useful. But I do think it's yeah, the main issue is whether the whole thing S from the beginning, the whole system has to be defined as a singular system that has behaviors, and we can like understand what its behavior set is and restrict it to its parts in some way. So yeah, that is some baggage there already.
My point is that, for example, don't we need to suppose a body here to talk about parts of the body, right? We cannot talk about constructing bodies out of constraints. We can only talk about analyzing bodies in terms of relevant. With this, I mean, as far as this went, right?
Yes.
Yeah, because I started to think like these constraints, they are useful to, it seems to me, to talk about that tactics and strategy part, in which like I was imagining, like you could imagine like how certain actions in a protest, like setting something on fire, will have repercussions for the whole. You're like ensuring certain directions for the movement, right? Whether there are maybe, I don't know, the fact that no, like how do you say carro de som, like like a sound,
like a megaphone, a guy with a megaphone.
Like a megaphone, like a big megaphone, like not bringing a big megaphone will allow for some like more like horizontal dynamics to unfold. But so there seems to, it's a really nice language, I think, to think about how actions, like action, like a part of a bigger thing making a certain action will ensure or allow that a certain space of behaviors is constrained in different ways, in a like non-local way. But it seems that like we have no information about the composition, like the body, like what are these organizations that are doing the actions, right? I think that's
I think that this brings me to the questions that I think were closer to a proper answer, but it should be also clear that it doesn't take us that far, because it's very, for example, when we were talking last time about the whole thing with the second text by that Liben guy, where the first one already had this idea that there's something which I think he doesn't associate it with it, but we could, right? That a time where organization of labor is so dispersed in the city, right? It's not a matter of factories, it's a matter of this sort of controlling partial actions everywhere, right? That assure valorization. It's a guy with a motorcycle bringing the food, is an app that tracks him, is the guy paying here, like nothing is happening at the same time in the same place. Right? And there is it's a weird kind of resolution from which you see all of this as a productive process. And political protests look like that today a bit as well. They also look like the gestures, as Andreas Wohlberg talking about, like these gestures are not really so cohesive with actors, right? So he takes the meme idea to talk about it. But the problem with the idea of gesture as the sort of best metaphor, and I was thinking about this as you guys were presenting, is that we cannot distinguish between contagion and constraint. Contagion is not the same thing as constraint, right? In the sense of, for example, though there's definitely a relation in the sense of, well, if you caused something in some weird way, it's still some level of constraining, right? But it seems to me that to give just one example, right? If you feel kind of tendentious that you should go to a meeting because if you don't go, it just looks bad, right? Kind of. You should go. You don't want to go, but you will go. It's a sort of constraint, which is not the same as a sort of mimetic constraint of somebody did it, now I'm gonna do it again. It's not because it's meaningful necessarily. I don't need to know what it means or to coordinate with anyone, but it just creates this sort of self-replication of a gesture, right? Self-replication, like, is like how do I put this? Like, it carries its organization with itself, right? It's replicating. The gesture is the thing that gives consistency, right? You can't really make anything else consist because of it. So one thing that I think we're starting to get close to is that when we can start talking about allowing, ensuring, it's a more complicated language to talk about how degrees of freedom how you can have an enchainment of degrees of freedom being constraining the other degrees of freedom in ways that are not like pure determination. So we could start talking about a bit more complicated language for how one thing conditions another, right? That seems very, very concrete, like a strike is a constraint, literally, right? All the way to this sort.
Yeah, I think maybe we can translate it so like gestures or whatever are behaviors. The constraint can be thought of as a measure of effectivity in a way, because it's anything that's like true or false, right? But let's say was the strike effective? That's a constraint. So, but then that would be a constraint on the whole. But we don't necessarily have a language for the part, like the quotient of or the partition of a successful strike, right? We know when we recognize a successful strike, but what does it mean to now take the part and say like, okay, what is the constraint on the part that allowed the whole to be successful?
Yeah, but this is why I'm a bit confused with the constraint and predicate thing. Like, yes, I understand that like they're talking about you get a predicate and it's either true or false. Okay. But when you're saying that the predicate is either true or false, it's actually that you're sending to the subobject classifier actually the mapping of a domain to a codomain, which has that predicate as the function.
Yeah, exactly.
So so we can talk about functions. It's just, let's say, functions that obtain. Right, which is better if you're talking about, right, things that it seems to me like when we're talking about predicates and seeing if things are true or false, it just seems like it's a easier way for analytically to describe if something functions, like if something obtained or didn't obtain, right? Like in terms of so I don't know, it just seems like it's easier for me to bring to a kind of organizational point of view, because like I like this way that Rosen describes it. He says, well, we should define components. They're equivalent to organizations what particles are for mechanics. Like it's the atom of a function. Like the minimal unit of functionality would be a component, something that if you remove, it affects the functionality, some correlate functionality in the system, right? Yeah, and then okay, you can talk about that component as being a predicate, exactly like we did with Badiou. But it's more obvious that what you're atomizing with predicate is a function. You're saying that that's a true value, right, for the function.
Because the insurance operator allows us to relate the behavior to the constraint.
Yeah, because ultimately can't we boil down the insurance and the allowance just to, let's say, two ways that you map? Like, is there an element that obtains or all elements obtain, right?
Yeah, across parts.
Across parts, yeah. So
Yeah,
it's a functional description, but in the bottom, right?
Yeah, it's a way to apply a constraint on one part to a behavior on another part.
Mm-hmm. So why am I saying these things? Like, it's because I feel like recently the best model we had, giving some rationality to a kind of multi-scalar idea of organization, which captures some of the things that usually people call disorganized as, well, a case of organization, was talking about gestures and the sort of self-replicating mimetic thing. That's an example we had, right? I have the impression that what you guys showed today is that this discussion of passing constraints, it's very strong in terms of starting to create a language to talk about this set of behaviors is constraining that set of behaviors, but there are ways of doing so. They can be compatible, incompatible, they can be determining one another, they can be in such a way that they're just, let's say, giving conditions to something else to happen or properly ensuring something else to happen. Like, it's much richer, right? But there is a big problem in our case, which is if you want to bring this kind of, it seems so natural with the whole logics of worlds approach, but if you want to bring it to not to talk about the logic of worlds and describe worlds dynamically, but to talk about bodies in Badiou's sense, then you need to have a way of defining the interiority from the constraints and not the inverse, right? Like the whole topology of the body, it's given by the point, right? Not the inverse. So that brings the problem that interests me, which is from where we are right now, actually, there is no distinction between, let's say, regularities and singularities in this constraints discussion. Like, if it's just going with the flow of the world, right? If the system is the world at large, or the system is a part of the world, there is no difference there, right? Like, nothing defines a certain special closure as of a part inside the world that we could call like an organization. See my point? Like,
yeah. I think yeah, I think you're right. It doesn't necessitate, it doesn't specify what model we should choose. It gives us the tools to create different models of organization.
Exactly.
So we could consider, in a protest, we could consider the group of people as our system that we want to analyze. And then we could say the individuals are the parts. But we could also think of a system where, like, the police and the protesters are the system, and the entirety of the police is one part, and the entirety of all the people is another part. So those are two different models, and the semantics or whatever will be different.
yeah, but I mean, this is why I think that there is actually a technical point missing for to turn this paper into something we can use, because okay, of course we can have this sort of, I mean, where we are right now, it's like Badiou added an extra chapter in the book saying how to talk about the greater logic in terms of actions, right? It serves the same fluid plastic kind of thing that the atomic logic does. You can choose any system and it will allow you to talk about the inner coherence of that arbitrarily chosen part of the world in terms of some predicates, right? That has a counterpart on the topology and the actual ontological structure. So we are not doing a surface kind of analysis. If you can cut it up in those ways, that has consequences for what's actually going on. But how you're going to cut it up that's not something logics of worlds is the greater logic is worried about.
Yeah.
Right. So how does this pass on to the second part of the book, which is then talking about, it's not like the general description of the world in terms of behaviors, but the actual, let's say, tools for talking about political process, for example. Because when it gets to the second part, Badiou doesn't describe the whole world in terms of decisions and points and topologies. He's trying to say that, well, if you pay attention to these things, they kind of give you the thread to make intelligible the consistency of a political process, right? Pay attention to points, the fact that points being compatible forms like consistent interiors, that these interiors have inner structure that you can define localized organs, right? And that these organs, they themselves keeps to some compatibility. So he's managing to tell you what to look for without telling you what will count as a point, what will count as an organ. So it's a very kind of flexible way to talk about it, right? So I'm wondering, when we transcribe those things which are described in terms of inquiries and very loosely talking, right, in terms of these bodies and organs, when we redescribe them with this machinery, I don't think it's so, the interest there would be to say, choose any part, predicate on it anyway. That's, let's say, the exercise for learning the atomic logic, kind of, to learn to see things in that way, right?
Mm-hmm.
But when it comes to the theory of generic processes in the end, I think that there's something slightly more specific that we should be looking for, because then I think the question we're interested in is we have an idea of these points as things that obtain some predicate, right, on the true and false for some inexistent subset in the world, right? They redescribe things as having properties that they apparently didn't have, right?
Mm-hmm.
Does that make sense? Like, for
You're
example, I'm
talking
just taking the
about novelty.
Spartacus example, right? When he says the slaves can go home, it's literally an allowance, right? I mean, if we're these people, then it's possible to go home. It's not saying that it will happen, but it can happen. I'm just trying to, you see my point? Like, what we're looking for something specific, it seems to me, which is like looking for ways to extract constraints from non-formed parts of the world. Right? I mean, isn't this?
Yeah. Well, I think,
Yeah.
you can.
So,
go ahead, Yasha.
yeah, I was gonna say there's, well, sort of off what Gabriel was saying, it seems like there is already something that points to what gives like good explainability in this circumstance, right? Which would be, or like what is like a good part to look at, for example, would be one that constrains many other things, that either allows behaviors on many other parts, or also it ensures behaviors on, or its behaviors, I mean, ensures behaviors on many other parts. Meaning that they sort of like interact with the system quite a lot. So for example, I mean, in back to the example of like a dance performance, if it's like something like a ballet, we could say that the main dancer is like in some sense a larger part because they play a larger role, right, in the full thing. Their actions are a bigger part, take more space, and ensure and allow more things with everything else. And I don't know, I feel like the point, like the inexistent, right, that would appear that wasn't there before could come about as something that isn't seen as a part before, right? There's some
exactly
encyclopedic knowledge.
I think this is where I wanted to get at. Like, I think the thing we learned from the text on the gesture is that there is a mismatch between all other ways of describing a world and the way that is based on constraints, like, which is positive for politics, because
Yeah.
some things are only intelligible as constraints and not as actors. That's the point about radical actions versus radical actors, right? So I don't think we should be that interested in the the overlapping, the equivalent descriptions between constraints and other modes of predication. Like the fact that a lot of, just a second, my dog is eating. What are you eating? Okay. Like the fact that you can describe, for example, a dance in terms of the costumes, the people, infinite set of predicates, amongst them the behavioral types. There's some equivalence there. You'll be describing the same world, right? You can slice them up in these many ways. Whereas there's something about political side, for example, something about the fact that workers are constrained by their family social reproduction conditions, even though those don't appear in their jobs. But that's actually constraining the job, right?
Yeah.
There are some things that only appear in the constraint mode. So it's not a full overlap. There are some things that are more intelligible from that perspective. And I think that's what makes this discussion interesting for the project. It's not how equivalent it is with the other modes of description where no sites are at stake, but precisely that where sites are at stake, you won't be able to describe what is underneath the atomic level or below the inexistent in any other ways, but capturing what it can constrain, right?
Yeah, I think
my point,
workers, the workers were a good example, I think, because you could say that like a workforce, right, that maybe isn't organized in some way before, that maybe goes on strike for the first time, right? That is in the way in which that's like bringing some inexistent, right, like more to existence, is it's these workers are realizing that their work ensures that the work gets done, and also the other way, their non-work ensures that nothing's going to happen, right? Without them, the work won't get done. So if they all strike together, then they can make some demands, right? So that's already like, if that was something inexistent, by like noticing something about these constraints, about the insurance of their own work, what their work like means, and that if they can deny the work, what does that mean for the employer?
For example, you see a good example based on this, like the difference, like which is a classic case, in fact, like workers realize that if they, let me put it two ways. One will make the experimental character clearer than the other. So the classic way is militants tell factory workers, mostly men, that they are revolutionary subjects because they are the workers and work makes the world goes round. So they stop. They're radical actors. So they stop the factory. The factory actually stops because they stopped, right? That confirms that they are radical actors. But the fact that they can only remain in strike because there are women taking care of their children, so on and so forth, that remains, like, that actually constrains them, but that doesn't get to have any say. Whereas if you have the inverse, which is you find out what you're capable of, because, let's say, I constrain, we stopped working, the factory stopped. But you don't know what you are, you just know what you did, right? Well, now you know that if the women stop, you also stop. So you can't really take yourself to be the radical actor because your constraint is dependent on a different constraint that's coming from somewhere else. Right, which is something that started happening in Italy in the 70s. Like there were the strikes in the factories, and then the wives of these guys would strike on taking care of the children, and then they couldn't keep the strikes up because they are not.
The women were the real strike breakers.
Yeah. So the point is that there is a. You see my point? Like there is something that's. Yeah. There's a bit of a prevalence of the constraint over the identification of the actors, right? Which I think is the sort of topic that they're trying to articulate in that text. But since the only kind of thing we recognize today, the only two discourses about propagation of behavior that we have is viruses and memes. You either will compare politics to viruses or you compare politics to memes, because we don't know how else to talk about propagation of behavior, right? And I think this is the crucial part. If the behavior comes from the standpoint of the inexistent, it will be disjunct from the identity. I think we could almost prove that as a theorem in Badiou, right? If a form arises out of something that is inexistent, it cannot be equated with the self-identity of any already existing actor. So there will be a disjunction between a certain constraint that can be passed along a certain form and the people who existed, right? Like the identities we have available. It won't totally coincide. We won't be able to say that that fully belongs, it's fully identical to anyone.
Yeah, or even using compatibility. We could say it's like there's no compatibility with this inexistent and any other.
Yeah, exactly. So, I mean, we can actually start deducing a sort of figure where a constraint is put into circulation that it's not fully compatible with any existing part of the world, right?
Yeah. So definitely this paper cannot formalize that notion of change, but once you have that inexistent, I was thinking this paper enters where you have the inexistent and now you're trying to construct the organs which support it, let's say.
Yeah, but the inexistent, yeah, but this is the part that I don't understand. Like, it seems to me like the body, I mean, the way that I would draw it, and perhaps I'm taking it the wrong way, but like the way that I would approach is saying that the inexistent is here, like in terms of order of construction, right? Then you have, yeah, actually that's not true, but you introduces the body and then the organ.
Yeah, because to translate from Badiou to this paper, which we definitely lose something, but we can translate the inexistent to being a new statement that is let's say it's a behavior, right?
Yeah.
It's a new behavior that didn't exist before, but new behavior type. So the new behavior type in the case of the workers is like no longer just workers, they're also radical actors, whatever.
No, well, yeah, I don't think that couldn't be a statement. I mean,
okay, yeah, that's not a good statement. But let's
take
say
the Spartacus one, like,
yeah, the slaves can go home.
Yeah, slaves actually go in the direction of their home, right? Which is a degree of freedom that wasn't available.
Yeah, so that's a behavior type that didn't exist before. Now we construct the organs around this entailment operation. So if I don't know if you put on the left or the right, but let's say the inexistent is on the left here. Then this is another statement that we don't know yet, but it has to be discovered by the the movement. And when you discover it, for each one of these you have an organ that has to uphold this statement. So then you create the lattice from the inexistent statement all the way down to all the other statements that follow from it. But then this paper comes in when you have two organs, they both uphold the original, they have some relation to the original statement, but we don't know the relation between these two organs. And that's where I feel like this language of constraints might work, because there's some constraints on this organ which do not exist on this organ because they haven't really had any contact, but they both have a relation to this top statement, like the slaves can go home. Okay, they both affirm that. That's the only point of commonality they have. So now what tools can we have to transfer constraints between the two?
Yeah, but
So
that's the part that I disagree a bit, because you see how much you had to you had pretty much to assume that a fully consistent political process has happened, and we're coming in to talk about how to talk about it. And I have the impression that you can actually use this stuff a bit before. I mean, I'm not sure if I'm totally off the mark here, but I mean, the way that they pass from compatibility and determination to allowance and assurance, doesn't that require that we are not in a localic topos to work? Like to pass from the behaviors to the parts in that way.
Wait, why?
I mean, I'm just trying to understand, because like my idiotic understanding of these things, like the reason why Badiou maintains the postulate of materialism and it's so worried about these things is that you actually need to have like a small part of the multiple obtained, right, with the decision. Like you need to actually kind of split the world. You can simply, for example, introduce a statement, right? The statement needs to have some material thing in the set there that actually guarantees it. And it's with those little things that you actually build up the body, right? It's not a discursive thing. It's not that they share predicates. That it's actually on the sets, right? That's why people say it's too restrictive in a way, like with the machinery.
But
Yeah, but this don't we get behaviors as things like this, right? You can see which behaviors happen.
Okay, but my
see
point
which
is
ones
that
happen.
yeah, but my point is that it still is like from the bottom up, like, and I have the impression that the operators are interesting when you're actually constructing the relation between points, right? The idea that a point, 2 points, they can have no constraint amongst each other, or they might have constraints amongst each other, right? So, for example, very clearly, like there is a protest. 2 groups might join the protest, right? They might join the protest in such a way that they're totally independent from one another, or they might join the protest in such a way that this is done in a way that one has its degrees of freedom restrained by the other.
Yes.
That actually implies more compatibility. No, that implies that we can have a way of talking about this where it might be more desirable to imbricate one in another, right? Than to have things isolated and with more degrees of freedom, right? In the same way, like a body is not just having a lot of functional parts separate. It's the fact that functional parts come to constrain other parts, right?
Yeah.
Multiple ways.
Yeah. So I think here we can read something like the composition of a body as having its organs be like very compatible with one another or something like that. No.
Yeah, like the whole join and meet of the behaviors. I feel like that's similar, right? Like you have behaviors of one organ and behaviors of another organ, and you want to make a new thing that combines them. So you take the join of the two. I mean, I don't know if that's useful, but yeah.
Yeah, I'm just trying to, I mean, because on the one hand, I think we have the meme example, which I think is the most, it has some truth to it, but it's very rarefied. And on the other hand, we have Apolito's whole discussion with complexity and connectivity, right? Which is going the same direction, kind of. You want things to kind of propagate something, but you can't really just think in terms of increasing complexity. You also are trying to latch one thing onto the other, right? That's what kind of makes it different from, it makes it more economical than rather interventionist, right? And actually gives contemporary politics a more economical look than an interventionist look, weirdly enough. It's interventions that look like a panic movement, which is the markets movement. Markets behave like panic structures most of the time. So popular revolts today look like economies in a certain way, perhaps more than organized action, right? So there is this kind of concern with, let's say, interesting conditions to have in mind that to make intelligible, to increase the chance that the combination of those things that they compose to form things with certain structures, right? So it's, let's say, the bodily construction kind of point of view on constraints, right? Rather than the analytic aspect afterwards. Like that's the part I'm trying to see if this doesn't have some consequences to it as well.
Yeah. I guess the thing is, I mean, we don't in any political situation or any kind of situation, really, the behaviors are unless you're modeling it on a computer, the behaviors have to be discovered, right? And this, all of this formalism, it's only useful once you have organized things into behaviors. But let's say you're creating a new group from previous groups, or you're joining together, you might be capable of new things that you previously weren't, and you don't really know what the behavior type is. But then
you
again,
already
like,
need to have I think you already need to have an idea of what's possible, right?
Yeah. Then again, though, we know what protests. I mean, we've seen protests, we've seen movements. We can provisionally like come up with behavior types for them. I mean, I guess just like, it's hard to, when we talk about, I don't know, this strong change thesis that dude puts forward, it's hard to reconcile that with any kind of like modeling, right? It's something that is supposed to exceed a model.
Yeah, kind of, because I mean, this is where I think that's why I'm saying that I think that there is a change of how to use this language, because when we're talking about like world and atomic logic and these things, you are allowed, let's say it's okay to use a more classic sense of modeling, where we imagine a situation or we reference something, then we bring in this mechanisms, this formal machinery, and we see how it's giving us more intelligibility on something we already imagined, right? Or we already know. So we reference a situation and we talk about, there's a choreography, you can split it up in many ways and so on. But the whole reason why Badiou is doing this with all this mathematics, it's for that one situation where you cannot do this, which is things you cannot see from outside, right? You can only be inside of them and not take this outer look and say, oh, it's happening like this. You can see it in these ways, right? Which is a generic procedure, which are things that you can only get the formal theory, right? That's why it's the formal theory of the subject. There's no other thing to do. You're not modeling any real world thing. You're just, let's say, one, showing it is possible, and two, finding out, let's say, what is a way of increasing the intelligibility of those things, which from an objective standpoint would not exist, right? The sort of entailment structure we're talking about is just like the forcing structure, right? It's an entailment under conditions, right? Of one constraint on the other. It won't be a regular constraint. I mean, that's the difference between Badiou and, let's say, scientific socialism. Scientific socialism is saying that there is, let's say, direct implication. Something will happen, and therefore something else will have to happen politically, right? It follows from it. And for Badiou and this sort of line of thinking, it will never follow, right? Nothing from a material objective condition will make something subjective follow in that strong sense, right?
Yeah. So I think, yeah, I agree with that. But I think there's a separation between the subjective effect, which will the subjective effect cannot necessarily follow, but the the bodies that support that effect, I mean, you still need people to show up to the protest, people to, you know,
No,
have
I'm
free
not
time
trying
for
to
that,
make this
so.
into, I'm all in with this formalism, just trying to see
Okay.
where I would start applying it. And again, I'm trying to use this example of the mimification and these things because for me, it really clarifies, let's say in a concrete way, where we start taking baby steps towards this more, let's say, political economic view of Badiou, right? Because that's how economy exists. It doesn't exist as actors. It exists as constraints, right? You don't work because you're a worker. You work because you're unemployed. Let's say it's one of the points we were making. Like you work because you will die otherwise, right? You don't work because you are a worker. So
I think that's actually a good, that's a good place to start to try to apply some of those specifically, right?
Right. So I mean,
The
my
constraint
point
on the workers.
Yeah, but I mean, the economic point of view is always a bit like that, right? It is this sort of gestures that repeat gestures, things that constrain what you can do because of the amount of money you have, things like this. Whereas politics is usually not thought in those terms. Organization is usually thought more like actors who express their motivations and that demand things, right? So the mimification idea was kind of, look, you can actually look at contemporary forms of revolt as being more in line with the way economy works, this sort of impersonal, self-reproducing constraint, than looking at it in terms of agents, motivations, identities, and so on. So it's giving us a hint that there is a way to describe subjective action, bodies, experiments, and so on, which doesn't need to be described from the bottom up in the language of actors. It can be described from the bottom up in the language of constraints. That's how I was reading the connection. So we need this sort of behavioral grammar because it's a grammar that is going to make the constraints intelligible with a bit less regard for the actors, right? You can ask questions of this is a radical group if it produces radical consequences, not in terms of because people identify in this or that way.
Yeah.
So it's leading us in the right direction, I think. And the ultimate thing it can do is, in my opinion, the thing that I remember, I think I told you guys, like when I was in Cuba, I was talking to this girl in a bar, and it was like 4 p.m. And then she looked at the clock and she said, "Oh my God, I need to run. I'm so sorry. I have this really annoying neighborhood meeting to decide what we're gonna do with the neighborhood fund. And like I need to go. I hate it, but I need to go. Otherwise, people will just, mock me." And I was so kind of blown away by. Imagine like it's the thing we were talking about the other day. This kind of weird inversion between organization and environment, right? It's not an organization. It's just the environment. Like that's a self-replicating constraint on her life. Like nobody's voluntarily, ideally thinking about it or fully committing to the neighborhood meeting. Nobody cares, but they cannot not do it, That's, I think, a good movement from organization to this sort of economic point of view. It's not like a profoundly voluntaristic kind of attachment. There is no actor, like radical actor, right? So it seems to me like this language of constraints, it can take us all the way there in a way. It's cohesive with all these steps, the subjective extracting of a form, which concerns social relations, a description of political action that is more focused on the action than on the identity of the actors, right? We can deduce the identity from the actions, but it's also conductive to talking about this more environment point of view, right?
Yeah. Yeah, exactly. I think this is like a language for the day after, right? GGX.
Yeah.
Yeah, that's a good way of putting it.
So, and yeah, sorry, Renzo.
No, I was. I mean, I'm not sure how the way I was trying to feed this, because I think it's really useful. Is and I want to see if I'm understanding where the discussion is going, because like you have, because we have a certain part which we don't know what it's made of, right? So it's something that's kind of like done without and we don't know what it is. So it's not an actor, it's an action. So it's something that goes out into the world or into a certain part. So this would be kind of like the gesture, some kind of like singular thing that starts, and then we're able to learn some effect by observing somewhere like in the world. We learn a certain constraint that this action produces in the world or in another part of the movement, right? We're able to collect this information somehow. So the way I was trying to picture is that, so in this step where there's some information that's being learned about this certain action we perform by assessing like how compatible the behaviors in other parts are with whatever we are, and how incompatible whatever we did is with the world. So and at that point that you so in this sense this integrates like a certain perturbation. So an action like a gesture is some sort of perturbation which you use by learning the kind of constraints it imposes into other parts. So for example, a negative constraint in the sense of like a blockade or like a blockade or a strike, but also like positive constraints in that you learn compatible behaviors between other parts of movement, right? So, and at that point where you learn these behaviors, this starts, you're able to, you can incorporate it as a part of what you are, like, then it starts to build. So when you organize for a certain blockade, and then you in the text he talks about a lot about place making, right?
Mm-hmm.
Which is the sort of stuff that you learn that you need to do in order to guarantee a certain duration of this effective action. So it seems to me that this relation between that this it's kind of like this process of transforming like singular gestures into kind of like known forms that start to reproduce inside the
Mm-hmm.
inside the body. So it's a way, and in this sense you gain information and you gain form because you learn how a certain action that you didn't know what it was or what it did, you now are able to collect this information and kind of like like inform the body in a kind of like subsistent way. So what was this does this relates to the discussion?
Yeah, I think learning about it is definitely one aspect, but also I think why not also like enforcing or creating synthetically relations between the organs. Maybe the organs, maybe they're just letting the organs behave on their own, or let's say letting the gestures behave on their or happen on their own, or this mimetic thing. That's only step one, but then like there's an additional step of inventing new constraints that somehow can apply.
Yeah, because I think that what Renzo is talking about actually it presupposes one step that I for me it's the most interesting one, the really one that I'm curious about, which is, for example, in this language, when for example, we spoke about the example of the choreography, and we got to the point of the sort of atom underneath which a certain behavior makes no difference, right? Two behaviors are just the same. So if you did some movement and you had watery eyes, or you did the same movement and you're sneezing, they're the same movement, right? So there is a certain, the other side of the constraints, it's also defining, let's say, resolutions that are relevant, right? So this brings a problem for politics, which is not every gesture is a constraint on the consistency where politics is happening, right? So that brings us to the weird discussion we were having on WhatsApp the other day, which is you can talk about the sort of sensitive membranes of the social of people, for example, right? Memes have very much that idea that they have this sensible kind of shock with people, and that also leads them to reproduce. It's not an intellectual process. It's much more, let's say, bodily, the way that it hits people, and they can reproduce that gesture or take it further or something like that, right? But that's not a given in this approach here, right? Depending on what behaviors you're examining, what counts as a behavioral atom can change a lot. And you can have constraints that are being passed along, right? But they have absolutely no bearing on effects that are relevant politically, right? So for example, you have a protest here in Rio and people decide on a chant, and that propagates amongst the people and they all are chanting the same thing. But well, the police doesn't seem very moved by it. And they changed the song, and it's a constraint that is propagating amongst the protesters, but it just propagates in that field. It doesn't propagate towards the police, towards the people around it, towards anywhere else, right? If the media is too far away, it won't really even get recorded or anything. So you can having constraints being propagated is not enough, right? There is a level at which, that's where I think the organs are really more than just parts, right? Organs are parts plus a resolution, perhaps, right? Which makes them sensitive to some relevant information and not just to information in general. So like there is something about the machinery of this middle step, right? Between talking about constraints, constraint passing, and so on, talking about this more consistent experimental dimension of.
But it's like the dimension at which the resolutions are produced. Is that it? Or
Yeah, something like that. Like
Yeah, exactly.
I would separate those two things, like.
Yeah,
Because-
and about the experimental dimension also, this connects to the insurance and allowance, right? Because allowance with experiments, you can verify immediately, right? If one behavior allows another behavior, if you see them both happen at the same time, then immediately you know it's possible, right? You know they're compatible, it's in some way. But insurance, you can never guarantee just by seeing it. You can see many examples of two behaviors happening together, but then never know if one insures the other. But you can disprove insurance, right? You can see a counterexample. You can see that one happens without the other and know that one doesn't insure that one, right? So that's, I think, like the connection to the experimental character.
Yeah, I think that this is really something I've been thinking about. Like I have the impression that bringing again that there is something about this discussion that will allow us to show ultimately that contemporary revolts are pretty much classic kind of actions, just from a different kind of scale. Like the same way that we were talking about the sort of work structure being very dispersed, but that's just spatially dispersed. That doesn't mean, or temporally dispersed. That doesn't mean it's not logically connected, right? It's just not logically connected for us, right? You might not know how much your data in your computer is connected with that other process and that other process, but ultimately, if you are less concerned about making things clear for individuals, it doesn't mean that the logical structure has changed that much, right? You just need to adopt a weird position to see that those things are still connecting, right? Somebody's working, something is being extracted without their being paid. This actually goes into, so that chaining is kind of connected. I have the impression that the whole idea that something about revolts that don't have a clear demand, they seem to be dispersed, fragmented. I mean, from a slightly different point of view, they're actually quite cohesive. Like they do interrupt some things, they do have their own consistency. So I have the impression that there's something about this kind of more economic look at organization that also has a kind of it looks like you're generalizing something rather than just describing something contemporary. And I don't know, like I think that if we can make that middle step a bit clearer, like you can, I at least for now, I can see in which sense, for example, when we're talking in the primer about cooperation in the factory or whatever, like very classic Marxist theme, and you talk about, well, there are things that cooperation can do as a collective worker that is not registered as existing for commodities themselves, right? So there are forms there that don't get to like their effects are part of the world, but they are themselves not part of the world, right? So you can extract surplus value from those forms of cooperation, but you cannot connect those forms of cooperation to other things in the world directly, right? That seems like something we could describe in terms of constraints. And I get the feeling that on the other side, we know how to talk about, or at least we have a vague idea of how to talk about a movement, bodies and parts and so on. The part in the middle that I'm really struggling to see how it connects is how do you create something that can assess what was the effect, right? I mean, that's the part of this mimification thing that bothers me a bit. Like it's always ultimately it's for us, like ultimately it can count on the fact that it's taking place at a level we can see and directly in some level directly kind of see a flow going in some direction. If you give it 1 degree extra of abstraction or of kind of, or of, let's say 1 degree of distance away from not embodied, but like presentified personal engagement into something that you're doing while you're passive, or you're doing without knowing, or that you can't never really state you are doing, but you can only state that some people are doing, like the Waltz example that Dennis gave, right? The moment that you move it a bit further away from that personal level, it seems to me like you need to account for under which conditions you're able to see the effects, right? How can you even know if something propagated? That shouldn't be a given, right? So that's where the behavioral resolution thing, I think, comes in.
It's like is it related to the, like having a theory of so on the causal geometry from whole, like you have these spaces of this, you start with a space of interventions and a space of effects of interest, but you also would need a theory of how, for a given organization, which kinds of intervention, which kinds of effects you're able to do and to evaluate. And this could be given at scales at which exceed, right, the individual, which don't register at the level of the gestures of the people in the protest, right? So you also need that, like there is the whole theory of scales, right, in which you can express that there are scales at which coarse grains at which this information is more efficient, in the sense that you can assess these constraints, the necessity and the sufficiency of these constraints are bigger, like you have more determinism, less degeneracy. So you have
Yeah, for example, exactly. But for example, a concrete example of that, like something that from the beginning always bothered me a bit. Like in a company, it is true that, for example, workers know much more about the working conditions than their bosses, for example, because of the way they are connected with the process happening, like how much things depend on them and how much the common part amongst them of all those things happening and so on. But on the other hand, there's something that the company sees better than the workers, in the sense that, for example, knowing how certain sectors depend on one another in the economy, it might be easier to see by looking at the things coming in, like commodities that are arriving at the company, commodities that it's being able to ship. Sometimes just you as an individual looking at your bills to pay or the prices in the market when you go to buy stuff, that gives you you're a very poor sensor for how, let's say, an economy is going. Whereas if you have many more sensors or things that don't simply are not simply, let's say, consumer kind of relations, but actually producer talking to producer, you might sense more complex information, right? So there is a correlation between, let's say, how these things are composed together, right? It goes into that other topic that we started researching with this resource sharing kind of theory, right? Where it seems like once some parts of the world overlap in some ways, they become more capable of evaluating effects, or they are more, let's say, taken up by constraints, right? If you're like, I don't know, if you're on the water in the beach and the wave comes, if you're in certain positions, that will make no difference to you. If you're in a slightly different condition, that makes a big difference. So there are specific conditions for constraints to be relevant, right? I feel like that's where the instrumental dimension of the experiment comes in. Like, how do you instrumentalize an organ so that it can be sensible, right? Sensitive, sensible to some constraints. That is what makes it into a certain experiment, right? It's not a given that, let's say, if you are part of the same movement, that things will connect, or that things will constrain each other, or that you can even, I don't know, I'm beyond tired now, but you get the feeling of the problem that I think, we should find a way to fit into this discussion somehow.
Yeah, I see your point, because I mean, we gave these blobs at the beginning, and they're like, we didn't really talk about why are these part of the same system? What makes them belong to the system? And
yeah, that's why I said that the BS here has some arbitrary, like it will just fit whatever we want it to fit.
Yeah,
exactly. Yeah. But what you're talking about is a more materialist view, that like in order for a system to in order for us to call a political movement a system, there has to already have been some sensible parts of it that can sense each other, and the kinds of effects that the other parts of the movement are producing. Right?
Yeah.
Something like that. Then
I think perhaps the
prior condition.
Yeah, perhaps that's where I said, that's why I was insisting on this idea that somehow in the theory of the subject part of logics of worlds, you need to actually build the trace of the event is supposedly, let's say, the new kind of classifier, right? If it connects with it, it's going to be in. If it doesn't, it's going to be out, right? You can construct an interiority, like you're constructing the system. The theory of points is also constructing a sort of system out of implicative relations, right? But it needs to, you construct the body at the end. And of course, it is a kind of, it's not just bottom-up process, it's both ways, because once you have a body, you have organs that also allow you to have a bigger body and organs, but so you don't need to choose which comes before which, but it seems to me that that's where the discussion we were having last time in saying, well, you need to add reproduction and not simply have the process as the only way of describing this, because I have the impression that to have a process, you can talk about simply something being passed along, but to have reproduction, you need to have a way of assessing, let's say, internal effects, external effects, like that becomes an active kind of part of the grammar, right? For example, you can have actions that have absolutely no external effect, but they reproduce the organization, right? Or and even in a larger sense, like an ecosystem where actions between organs of the left, they're still very, very relevant. They might not be not look like they're changing the correlation of forces, but they're keeping the consistency of that ecosystem alive or something. So defining what the system is from the relation between the parts, I think it's more relevant to our part of the project than it is for them, right? For them, it's very scientific, it's good that it's arbitrary.
Yeah, but even so, I mean, they choose very deterministic systems as examples. They choose like bicycles and stuff. We're saying let's take a part of the world that wasn't considered a system before, and now it like becomes a system.
Yeah.
On the spot, let's say.
Yeah, I think that's the whole point. Like that's the whole problem. Like, can we use constraints to find the system, right, and not use constraints to analyze the system? Like,
yeah,
it's not simply that we have a system but we don't know the constraints. Like with the political process, you sometimes the only thing you know is a kind of a general vague statement. You don't know what is the body of that statement, right? So seeing what is implicated by a statement that is not necessary, right? That's pretty much something that's most of militant think.
And, but how?
I think the part of the showing the system is that we have to show that this restriction exists for every one of the parts, right?
Yeah.
And it's like basically like building up this like fiber bundle thing, right? We're trying to take all these behaviors of the bigger system, whatever it is, and somehow bundle them up as behaviors of the all the subsystems.
Because I think that to conclude, guys, like the place where I see this being very, very kind of being really crucial is that, for example, for Badiou, the fact that this is an invisible, kind of inexistent principle of synthesis of the system, it's kind of counted as this sort of ontological principle. You're trying something new. It's not going to be visible. It's not objective. And it's because you're engaging with something new, that things that looked unrelated, you can find their common part, right? And how through that common part, they are implicated. And I think that we're also assessing if we cannot give a bit more of positivity to this invisible, inexistent kind of standpoint, because the economy is an invisible kind of standpoint on its own right? So can't you give a bit more of positivity to this sort of, not necessarily at the first moment, but at some point, can this gain enough traction as a sort of dynamic to serve as a stable, invisible standpoint from which you can start seeing how things are connected, even though they're not connected from the standpoint of the situation, right? They will remain not connected from the standpoint of the situation. People can always say that the protests that were done here, the people who are doing that, the commune there, they talk amongst each other, but they're not talking because they're building something. It's because they're all part of some terrorist group. Done. You dismiss that they are actually passing on singular constraints amongst each other and so on. You just turn them into, let's say, they're all constrained by the current terrorist thing, right? So it can preserve the property that Badiou is interested in, the fact that this is a partial, engaged, antagonistic world outlook, but it could have a bit more of substance or a bit less dependence on the sort of militant kind of engagement with the what doesn't exist, right? We're almost trying to like detour the idea of economy to say economy is all about, you know, moving from faith to belief. But belief is also has a good deal of inexistent things in it. So if you can move from this sort of more productive view of politics to this reproductive view where the dynamic is kind of included, right?
Yeah, I also have to go now, but I think the reproductive point of view is definitely a good place to continue this.
Yeah, I mean, I'm not sure who of you have this book, The Life Itself book.
Oh no, you told me about that
last month.
I really think
you have it.
Yeah, I really think if whoever can read chapter 5, like I can scan it tomorrow. If I'm not sure if Yasha has it or Dennis. Do you have it, Dennis?
Actually, I thought I didn't, but I just looked up and I do.
It's just on top of it.
I might have a PDF of it.
Man, it's impossible to find the PDF. I'll scan it and send it to you.
No, okay.
Because just that chapter 5, it's called Entailment Without States, and it's a definition of organization as this really weird thing. He says an organization is an attribute of a natural system which codes into the form of an abstract block diagram. And he defines what is an atom of organization and what is the molecule of organizations and so on. But it sounds a lot like what you guys were presenting, plus some specific causal structure. Like if you take behaviors and you further constrain them such that they must be kind of trapped between kind of input-output arrows between the environment and the internal space, and also entailments within the internal space, right? So you cannot simply pass on something that came from the outside in and then from the inside out. The inside needs to entail the inside as well. Something like that, like a very basic principle. Then he starts to construct something very similar to what you guys were doing, but with a sort of reproductive point of view, kind of. So that
That's
might
perfect.
be good. Yeah,
So
I think it has a lot of connections, you know.
Yeah, we should definitely find a good like section of that to read next time.
Anyway,
Yeah,
guys,
sure.
sorry. Yeah, I'm sorry. I was a bit annoying today. I stopped smoking, so now everything is weird.
I have to go.
See you guys.
Okay.
Good meeting.
Good night, guys.
Bye-bye.
Take care.
Yeah.
Bye, guys.